हेलो।
कौन है सर?
ऐसे तो
सर ज्वाइन होते हैं बड़े सर?
ऐसे तो नहीं, उनका वीडियो ऑफ रहता, लेकिन ज्वाइन तो होते ही हैं।
मेरे नाम का भी कहता तो कौन है सर?
वसीम भाई, एग्जाम कंट्रोलर। हेलो।
जी गुड मॉर्निंग सर।
अस्सलाम वालेकुम।
वालेकुम अस्सलाम, कैसे हैं?
बढ़िया बढ़िया, अलहमदिल्ला। आप कैसे हैं वसीम भाई?
जी जी अल्लाह का शुक्र है, ठीक ठाक है।
कोरोना वहाँ पे फैला हुआ है क्या अभी भी?
नहीं तो प्रिकॉशन जरूरी है सर, लेकिन पहला नहीं हुआ है।
हाँ, होता है ये, सही बात।
चलिए ठीक है, राठी सर का कनेक्ट करके बात करते हैं, ठीक है
हाँ
सर।
जी, हाँ जी, ठीक है भाई, ओके।
ठीक। वो आरिफ सर,
हाँ जी सर, बोलिए।
आवाज जा रही सर?
हाँ, आवाज़ आ रही, क्लियर है।
ठीक है, फोटो भी जा रही होगी।
हाँ हाँ, फोटो भी आ रही है।
चलिए ठीक है, थैंक यू।
आरिफ, आपका माइक ऑफ करो। आरिफ, 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 स्विच ऑफ द माइक। Yes, Mr. Ajay Godra. Hello. Hello. Mr. Ajay Godra. Hello. Hello. Mr. Ajay Kumar Godra. Mr. Ajay Godra. Yes, all participants, to all of you. Uh,
Morning, sir.
अपना कैसे होगा? Please just be a minute. Yes, participants, today Mr. Rajay Kumar Gupta will be taking the sessions. This session will be of 90 minutes sessions, and today's topic is IoT-based smart solar water pump for agriculture. IoT-based pump for agriculture. Uh, Mr. Ajay Kumar Godra, yesterday also I just read out his profile, and I take an opportunity to come over this solve the technical bridge. He is a founder and director of Innovation Lab, a ITTR Chandigarh Startup Initiative. Mr. Godra is innovator and mentor of Change Niti Aayog, Government of India. Mr. Godra has Internet of Artificial Intelligence. He has developed many products and having patent in renewable energy area. Mr. Godra has delivered more than 100 expert talks via contact modes and IST based. He has trained more than 20,000 players. My suggestion to all of you is that it's better that we should try to raise, in between also we can raise some questions, some doubts. And before end of sessions, also we should try to raise some queries, some doubts, so that whatever new things we are getting, we should get it fully clarified. So he'll be shortly at his level. He is finding some difficulty with the system. Yeah, yeah. Mr. Ajay Godra. Hello. Hello.
Am I audible right now, sir? Voice is coming.
I just put a request to
I'm not
you,
able to
slightly
hear
raise
your
your
voice.
voice. Hello. Hello. Hmm? Hmm.
Hello.
Yes, now we are getting you, sir. Yes, good morning to you, sir. Hello. Hello. Hello, Dr. Ajay Kumar.
Betul. Biskuit lang yun.
Am I audible, sir? Voice is coming now. अब
is audible. Sir is audible.
Sir, audible,
okay, sir.
audible,
Thank
sir.
you.
Now you're audible. Yes, yes. Now you can take over.
Sir, thank you so much. Sorry for inconvenience.
It's all right, sir. It's all right. It's a very good topic, sir. Latest topic: smart solar water pump for agriculture.
Yeah, very good morning, and sorry for inconvenience you faced. There was some connectivity issue. So now we are going to start today's sessions. So over here in previous session we have discussed about a very interesting topic that was about the use of Tinkercad. Now in this session I'm going to discuss some very interesting application that how you can use IoT for different applications. Like when we talk about agriculture application, so how you can use IoT over there. So first of all, I'll discuss briefly about IoT, and I'm going to start this session. So when we talk about IoT application in agriculture domain, so over there is wide application and there is huge scope. So that we are going to discuss over here. So first of all, I will discuss quickly about IoT in an industry 4.0, and the same thing we are implementing in agriculture domain also. So let's get started. So these are major industrial revolutions that happened in the past, like hydrogen fuel, and the second one is electrical energy and mass productions. Third one is telecommunication. These are past industrial revolutions. Now we are living in the era of industry 4.0. So when we talk about industry 4.0, over here you can see that major area is being covered up over here in industry 4.0, like major title over here in major buzzwords in industry 4.0 over here, that is robotics, cloud computing, and IoT. So these are major areas over here. Those are concerned with industry 4.0. Industry 4.0 is nothing else. It's like a smart factory. How we can build factory. Same thing we are going to implement in agriculture also. That is agriculture 4.0. So that is the new term in agriculture sector, and over there, how we can implement our technology in agriculture and how we can make farm smart and how we can double income, because government is also going to do a lot of intervention in a farming sectors to increase or to double that farmer income. So what are the possible way? So when we talk about in a production capability, we are already in a peak. So there is no further scope, and we can increase only 1% to 2% in a crop productions in terms of the seeding and cloning and all that. But there is a lot of intervention is required in agriculture domain, technological intervention, because a lot of wastage is going on in the agriculture sector. Like sometime any kind of storm get hit the farmers, sometime there is some weather impact over there, sometime hazardous animal going to put a lot of impact in their crop. So that can be avoided using technology intervention over there. So that we are going to discuss. So when we talk about IoT ecosystem, over here you can see, like see, and you can visualize like in coming 5 to 10. So you will find that kind of automations in our day-to-day life also. Like as you are going to wake up, and after getting up, you are going to get dressed using fully automations that you can save it. And after that, as you're going to wear your suit, your car will come automatically from the parking, and you will able to, I mean, using some sensor, and the driverless car is coming in upcoming days. That you, so when we talk about IoT, so what exactly is Internet of Things? So over here you can see that IoT. So in IoT over there, we are going to see that what IoT is exactly. So over there, three major components like sensor and actuator, and second one is people and process. And when we talk about sensor and actuator, so let's see how we can use it. So first one you can see over here, that is sensor and actuator. So when we talk about sensor and actuators, so these are different type of sensor we are using for different applications. Like you can use some machine and vision sensor, ambient light sensor, and accelerometer and a tilt sensor for detection of different locations, and motion and speed detections. Then electrical and magnetic sensor. This sensor we are using in a mobile phone also. So then after that, leak and level sensor, that is also very much important in petrochemical industries and LPG pipelines. Then after that, you can find some more force, load, torque, and strain pressure sensors. This sensor is being used for detection of any kind of weight, any kind of load that can be detected easily using this sensor. After that, flow sensor, chemical sensor. A few of sensor we have discussed in previous class, like PIR sensor, ultrasonic sensor, and LDR sensor. Now over here, you can use some different sensor also, like force sensor and sensor. So these sensor are applicable in a different domain. So sensor is very much important. When we talk about IoT, there is two major important component over here. First one is sensor and actuator that depend upon specific applications. Like if we are going to implement IoT in agriculture domain, so over there we have to find some specific sensor that is being used in agriculture. In last week, I was in Agriculture University at Punjab, Punjab Agriculture University, Ludhiana, for that domain. So because in day-to-day life, we are using basic sensors, those are for learning purpose only. So when we have to implement any sensor in a particular real environment, real field, so over there, we have to select that sensor as per their applications, and their reliability also very much important. Then after that, connectivity. Connectivity depend upon application also, and for different application, we have to use different mode of connectivity. So that also very much important. So when we talk about connectivity, so connectivity, you can see when we talk about IoT, so connectivity is very much important point over there. So you can use some RFID tag over there for connectivities, and you can use LoRaWAN also over there. And what is LoRaWAN, that also I will discuss. Then you can use Bluetooth also, Wi-Fi also, and LTE and cellular network also. And when we talk about smart agriculture or monitoring and controlling solar water pump, so over there we are going to use that LTE or LoRaWAN technology. So in LTE, how we are going to use that technology? LTE means that mobile communication we are going to use, that GSM technology we are going to use it in a solar water pump. And similar way, when we have to implement IoT in an agriculture domain, over there, either we can use that cellular network sometime in a farmer, in a field over there. It's very tough to find mobile network also in some particular regions. So at that time, you can use that LoRaWAN technology. So when we talk about LoRaWAN, LoRaWAN stands for Long Range Wide Area Network. So over here, we are going to discuss some basic mode of connectivity like Wi-Fi, Bluetooth, and how you can use Wi-Fi and Bluetooth and using that mobile network also for different applications. So after that, peoples and process. I mean, first we are going to acquire sensor data from the field, and after acquiring sensor data using microcontroller that we have discussed in previous class, then we have to send the data on the cloud. So how we can send the data to the cloud? For that, we have to use some mode of communications. That is second part over here. And then after that, after sending data on the cloud, we have to perform some analytics over there. So that is very much important when we are performing any analytics. So today I will show you some open source tool, open source cloud. Over there you can perform some analytics. And very important point, if you want to build your own IoT applications, that also you can build it. That also I will show you few things. If you are able to do it, that also you can do it. But for the beginner, I recommend you that you can use some open source tool, open source cloud. Over there you can send data easily and you can monitor that data easily. So both things you can do it. But sometime when we have to build some industrial applications, over there you have to design your customized cloud, and that you have to deploy it. So that also we are going to discuss. So when we talk about people and process, so this people and process is happening on the cloud. So if we are going to perform some analytics over there, like and if you want to control anything over there on the cloud, that also you can control it. And these are supply chain management. So and then after that, location and tracking, that also you can do on the cloud. Now after integrating these three process like people, process, connectivities, and sensors, we are going to come up with some more advanced applications. So those applications, you can see it over here. Some basic applications like connectivities. So we are coming up with some more advanced applications. So that you can see it over here. So in the applications point of view, first one we are going to talk about smart thermostat, connected car, activity tracker, smart outlet. These are some available in the market, so that you can build it. So now after that, we are going to talk about some more applications. Like over here, you can see it. This one is a street lines. So street line mean that is the name of it, and you can make some mobile app for tracking particular parking locations. So this one is problem in the India, and upcoming day that problem is going to raise more. So you can build some kind of application using these sensors. So how you can build that one? Smart parking. Like if you are going to park your vehicles in particular parking, so you will able to find particular vacant parking slot using mobile app. So these are more diverse application of body, building, infrastructure, and industrial. So these are concerned directly with us, like light, bulb, home consumers. So when we talk about home consumers, so you can see over here light bulb, security, pet feeding. These are like irrigation controller, like solar water pump, and smoke alarm, refrigerator, infotainment, washer, dryer, stove, energy monitoring. So similar way in a transportation and all other domains. So when we are finding some topic for building some IoT applications, so you can find few application over here, and you can start building project over there, because one student has to build some project, they are not having idea that which where in which domain we have to make some project based on IoT. So these are common ideas over there, student can work and can build their projects. Some compound application over here, like transportation plus smart cities. And I'm just coming directly to the market of IoT. This one is for digital farm, like cattle farming if we are doing, and in a rural area, that is major business in rural household. So they used to carry even into cattle, and they used to sell their milk and uh, different product of that milk. So that can be get also trackable, and you can make smart dairy farming using IoT. So how large is IoT market? So quickly I'm just sharing with you. Then after that, I'm coming in a practical exposure that how you can build small application for controlling solar water pump, controlling home appliance, or whatever you want to control or monitor, that also you can do it in a very easy way. So like these are market value over here. You can see in 2020, when we talk about 2020, so 2020 is being at all the prediction got shifted in 2021. So the market will be more than 1 trillion. So there is exponential growth in IoT. So when we talk about industrial IoT, you can see the vehicle is being get manufactured, and all the part is being assembling in a different supply chain, or all the part is being get manufactured in a different batch size. So you can see all the component is manufacturing, and their data is going on the cloud. So this in manufacturing domain also IoT is very much important. So when we talk about robotics and industrial automation, that then you can see it over here, that how automation is going on using IoT. And you can see in this production plant, one vehicle is coming out in 1 minute. So in 1 minute, one vehicle is coming out, so that you can see it. Now after that, this one you can see it, product cycle time. So now you can see over here how many manpower is working. Only limited manpower is working, and all the process is being carried out using IoT, and all the data is going to controlled in the some server or some control room. So that is very much important. So there is some more application of that IoT in a smart robots, and the robotics and IoT also get integrated. So like to fight that COVID-19, these kind of robots are so much helpful. Now we are going to enter in a 5G. So as 5G will come in the market, so the advantage of 5G will be over there is that, so in 3G only limited device were connected. But when we are entering in a 4G, like we are using 4G right now, so more devices are connected right now. So as we are going to enter in a 5G, so over there you can see all the devices, maximum devices, machines, clothes, all will communicate with each other using sensors and data. And you can see all the devices are connected. So there are some disadvantages also. Like when we are building anything, we have to work on the perfections. That is very much important. So in upcoming day, you will find some robots for home application also, and those robots will be fully smart. So you can build some own application also. Like this one is the example of faulty component. So you have to work on the precision part. And like this, if any student going to get placement in a company and those company are working with the latest technology, so they will not able to perform their job. So how boss will behave over there in the company, that you can see it. So like these are basic of components. Like this one is a capacitor. And if we are lacking with the knowledge of basic of a component and basic things, and like will get breasted. And if that capacitor is being deployed in an aeroplane, so what can be happen over there, that you can just visualize it, that aeroplane can get crashed. Now you can see the resistance. So you can connect resistance over there for some applications. So how resistance is working, that you can visualize over there. So this one is color coding of resistance. These are basic thing I'm not going to discuss right now, like LEDs, and like this one is a process. So this process we can control it. So over here, like temperature, we want to control it. This one is a manual process. So why automation is required? So sometime what is happening, if any worker is working over there, so they can sleep, and this boiler get bursted. So recently one incident happened in a NTPC power plant. So over there, that boiler got bursted due to casualty of that operators. So these kind of things can be avoided. How that can be avoided? For that we can make this process fully automatic using IoT. So if any kind of unevenness happening over there in this boiler, so that can be avoided, because all the data going on the cloud, and we can get some alert also, like something is uneven is happening over there. So that mobile alert also we can get it. So like when boss is available, worker is working like this. So these are microcontroller and micro. So like Arduino, we have already discussed. Tinkercad already discussed. Now we are coming to that use of IoT applications using Wi-Fi module. So this one is a Wi-Fi module. We can use Wi-Fi module for sending data to the cloud, or we can use some 4G and GSM module also are there for sending data on the cloud. So this one is one of the cheapest Wi-Fi module available in the market with the name of ESP8266. So similar way, one Node MC module is also available in the market, that also can be used, and that cost is approximately 250 rupees. So this one you can directly interface with the Arduino, and you can use it, and you can perform your applications. Now we are going to use this module, and we are going to use Bluetooth also for controlling any appliance up to 100 meter. So the different mode of communication we are using it over here, that depend upon the range, that how much distance we want to control any appliance. So we are going to use very interesting application right now. So that application is controlling mobile app. We are going to design it for controlling appliance and controlling solar water pump, or whatever we want to control, that can be controlled. So let's get started about that applications. Okay. So now we are going to open over here that online cloud application. Over there we are going to design a mobile app. So let me open it. So over here we are going to, let me share it again. I think that screen is not shared. Yes. So over here, what we are going to do, we are going to use it. So let's see how you can use it. So over here, first of all, you have to search remote XY, remote XY.com. This one I'm going to open it. So how you can use that remote XY, that is very much important point, and how you can run it. So I'm going to connect that remote XY with my cloud. So in a remote XY, a very important point is that this one is a online cloud and open source cloud. And over there, we are going to design mobile app. So how you can design mobile app easily over there, that I'm going to use it. So let's see how you can use it. Yes, let me shift my internet connections. So in this remote XY cloud, what we can do, we can design customized mobile app for controlling appliance. So how you can design it? Just you have to open that remotexy.com on the Google, and after that you can design your customized mobile app. So these are control element, you will find it over here. So first of all, we are going to make mobile app, and that we are going to control home appliance or any solar water pump. We can also control it using that app. So that I'm going to do it. So these are control panels. You can drag it and drop it like this, and you can drag it and drop it like this. So these are two buttons. Joystick, just drag and drop it. So now these are but different button. You can use it. You can use RGB controller for controlling light colors in different like red, green, blue. So now this one I'm going to delete it, and I'm going to use only two right now. This on and off switch, and this one is push button. So if you want to configure it like increase size, decrease size, all parameter, you can change it over there. So now I'm going to do few setups. So first of all, you have to go to view. In a view, how you want to see that app. So this one in a vertical mode. So I'm going to make it both. So if you're going to see your app in like this, so you can set up it accordingly. So both setup, I'm going to do it so that I can use it later on. So now over here, this one is my mobile app, and there is two buttons. So if you want to change background color, that also you can do it. Many modification you can do it over there in mobile app, and you can make a lot of customization over there. So how you can use this app in your mobile? So how that app is being get transferred in your mobile, and how you can write code, that is very much important. So first of all, I want to set up this button for controlling any pin in my microcontroller. So I'm going to select pin number. So when we are clicking on this button, so you will find snap to pin option over there, snap to pin. So over there, I'm going to select snap to pin. So you can use any pin. I'm using over here 12 number pin, or you can use 30 number pin, that depend upon your use 11 and 12 number pin. So let me come back over there. So yes, I'm sharing screen again. There was some screen got off. Okay. So now over here you can see it. So I think screen is visible. Yes. So over here you can see that okay. So over here I'm going to set up their pin number. So this one is snap to pin. So I'm going to use 30 number pin or 12 number pin or 11 number pin. So let me use 12 number pin, and for this button I want to use another pin, so you can use 11 number pin. So 11 and 12 number pin I have set up it. Like for this button I will give my control signal to 12 number pin in the Arduino, and this one button is being used for 11 number pin. So after doing this, we have to go to configurations. So we have to go to configuration at the right hand side. Click on the configuration part, and over there you will find Bluetooth, Arduino Uno, and this one is a Bluetooth module and Arduino software. So click on the Bluetooth. So by default you have to use it if you are using Bluetooth module. So you can select Bluetooth connection, device Arduino Uno, and you can use a module that is this Bluetooth. So, and you can make it apply. Okay. So first we are going to do it using Bluetooth, and after that we are going to use it using Wi-Fi. So all the configuration setup is complete. Now you have to go to module interface. So how you can interface that module? So these are software serial, and you can make it hardware serial also. What is the meaning of this? Software serial mean you can make any TX and RX pin of that Bluetooth. You can connect it with the Arduino with the 2 and 3 number pin. So mean when we are connecting any Bluetooth module, Wi-Fi module, all these device used to communicate via serially. Serially mean over there you will find two pins, TX and RX pin, that you have to connect with the Arduino. So when we are using hardware serial, so in the Arduino 0 and 1 number pin is being used as a hardware serial. But we can use software serial also. That is up to you, up to your choice, which one you want to use it. And this one is a baud rate. Baud rate of that Bluetooth is already defined, and that is factory set. So you no need to change it, so that you have to maintain it 9600 for a Bluetooth module. So if you want to change it, that also you can change it, but that you have to change it first of all in a Bluetooth module. So that is no need to change it right now. So these are configurations. So in configuration, we have selected software serial on 2-3 pins, and these are pins. Then this one is baud rate. And after that, we did configuration, we did module interface, and we have did all the setup in a views. So what did over here? So it and then view. So 3 parameter I have set up it over there. So after doing 3 parameter setup, what you have to do, you have to click on get source code. So this one is for getting code. So click over there. So your embedded C code will generate it automatically. This one is embedded C code. No need to write any single line of code. You have to just copy this code and you have to use it in the Arduino. So how you have to use this code? There are 6 steps that you have to follow it. So what are 6 steps? So you can first one is you can download the source code, or you can copy that source code. So I'm going to copy that source code, and after that install that remote XY library. That also I will let you know that how you can install that remote XY library in the Arduino software. And after that you can connect that Bluetooth module. So how you can connect that Bluetooth module? Click. After clicking, you will find detail that how you have to connect that Bluetooth module. This one is a Bluetooth module that is available in the market with a cost of approximate 200 to 250 rupees. You will find 4 pins. So like there is 4 pins. One is VCC, like 5 volt, ground, TX and RX. So you can see more detail over here, and how you have to set up it, that also you will find it. So this one module you have to select it, and these are module interface that we did it over there same. So you can see the connections over there. So like VCC, ground, TX and RX, that you can see it. So same way we have to make connections. I think screen get freeze. Yes, now it is working. So you can see over here, these are all the setup. We can do it. This one is Bluetooth module, and this one is SC05. In this setup, we did it same. These are software serial connections, and after that, this one is a connection of Bluetooth module. So over there is only 4 pins. First one is VCC, then after that ground, then TX and RX. So when we are selecting hardware serial over there in the setup, we have to connect the 0 and 1 pin with the TX and RX pin. So when we are connecting any serial communication device with the Arduino, we have to connect TX with the RX and RX with the TX. Like 2-3 pin, we have to synchronize it in that same way in a reverse connection. Like TX should be connected with the RX of the Arduino and RX should be connected with the TX. So why we are using this remote XY? What is the purpose of that? Purpose of that is that mobile designing customized mobile app and controlling appliance using that mobile app. So I'm just showing you, let it see that how you can use it and what is the purpose of that remote XY. So this one is working as a cloud also, or for building customized code, because sometimes we are going to make any IoT applications. So it's not necessary that only computer science student can build that application. IoT can be used in any discipline, and that is multidisciplinary domain in a IoT that we have to use it. So in a IoT, when we are building any application, so a student used to face a lot of difficulty while designing mobile app for controlling appliance, and also they used to face difficulty while writing code. So that we can do over here. So now, so whatever query, if you are having to any participant, you are having any kind of query, you can type in the chat box. At the end, I will discuss all the queries. No need to worry about it. So now I'm going to back over there in that editor. So in editor, whatever app you have designed it, that you will find it and get source code. And in the source code, we have to copy this code and we have to upload it in the Arduino board in a hardware. So I'm going to copy this code, copy it, and after that paste this code in the Arduino. So Arduino is having in my computer that is downloadable version. So yesterday I have shown you that Arduino software in a cloud version. So now I'm going to use Arduino as a downloadable version. You can use cloud also, but I want to show that how you can use Arduino software in a downloadable form in an offline mode. So this Arduino will get open like this. So I'm going to open new project. So over here you can open new using this button. So I'm going to open it. So after that, over here you can delete previous code and you can paste your code, whatever code you have copied from the Tinkercad. So this code I have pasted it over there. So after pasting that code, you have to add library. So how you can add library? You can go to that cloud, and on the cloud you will find remote XY library. That library you can download it. So click on that library, you can download it in the zip format. So over there you will find remote XY library that is being downloaded. Again, you have to go to that Arduino software, and over there you have to go to sketch and then include library, and you will find add zip library. So that zip file you have to add it from your download. So over there you will find that library. So let me go to my download. So over there I'm going to find remote XY. So these are library, I'm going to select it, open it. So after selecting that library, it is saying that library is already used over there. So you can add library easily. So after adding library, you have to upload your code. So I'm going to verify my code. Compiling process is going on. And after that, you have to upload that code in the Arduino. So that I'm going to upload on the hardware. So let me open my hardware. So I will show that how you can upload that code in the hardware and how you can connect that module also with the hardware. So over there, my compiling is done in the code. So my code is being get compiled. Over here, I think you are able to see it. So when we are going to compile the code, after compiling is done, we have to upload that code in the hardware. So how we can upload that code in the hardware? We need a upload it, and after that I'm going to connect Bluetooth. So we are having one setup for controlling appliance over here. Santosh Kumar Sharma, kindly mute your mic. Your mic is not muted. Santosh Kumar Sharma, kindly mute your mic. So that we are going to use it over here on a hardware. So I'm going to share with you that pic. So now I think you my video. Kind it. Okay, now what I'm going to do, I'm just sharing my video over here. So let me check video if you're able to see it. Yes, I'm just trying to share my bigger screen. So be with me. Okay. Are you able to see my video? Are you able to see my camera? Yes, you can respond here if you are able to see my camera. Okay, so let me troubleshoot it. Okay.
Sir.
So I'm just troubleshooting it. Be with me. Wait for a second. I'm just integrating it. Yes. Now I think you are able to see it. So
Screen
in
is
the
visible.
camera. Okay. So now in this, I'm just going to show you that hardware. So this one is Arduino board. If you are able to see in my camera on the screen. Let me turn off that screen. Okay. So are you able to see my camera right now? Okay. Okay. So in the camera, you can see it over here. Kindly click on that screen. You will be able to see in a zoom format. So that screen will get highlighted. If you are going to click on dear Santosh Kumar, kindly mute your mic. Your mic is unmuted.
85% पूरे देते
Sir, if you are able to mute Santosh Kumar, kindly do it. Okay. So over here, I'm going to discuss about this. So what, first of all, we have to upload code in the hardware. So how we can upload it? So meanwhile, I have just built it one application over here. So this one is the one application that I'm just showing you. Over here, I have just connected three relay module, and on these three relay module, I have connected one AC bulb also. So that AC bulb, I'm going to connect it over here, one CFL. So that CFL we have to connect it. So this CFL I'm going to control it. That is AC CFL that we are going to control it using mobile app. So over here, Arduino is also connected. Bluetooth module is also.
Sir, your screen is not visible.
The camera is visible.
Yes.
So I'm just okay.
Yes, it is visible.
Okay, sir. Okay. So in this, you can see it over here. That over there, I have connected one CFL, three LEDs over there, three relays over there, and one Bluetooth module is also over there. So this one is Bluetooth module as I have connected it over there. So this one is Bluetooth module. So now what we have to do, we have to upload code over there, and this AC bulb over there is two wire in AC bulb. So that two wire I'm going to connect it with my supply, with my AC supply. So these two wires, there is two wire, those are connected with my AC supply. So these two wires I'm going to connect with the AC load, and I'm going to control this bulb with my mobile app. So that is the purpose of that designing mobile app. So how we can control that appliance, AC appliance. So similar way you can control any kind of solar water pump or any kind of appliance you want to control it using mobile app at your home or as it in the industry also. So now I'm going to upload code in this my Arduino board. So my USB cable is connected over here. So that I'm going to connect with my computer, and then after that I'm coming back over here. So I have connected it with my computer. So power is coming in my Arduino board that you can see it. Power is visible over there, and Bluetooth module is also start blinking. So now what we have to do, we have to upload code over there. So whatever code we have used in that uh, Arduino, so that code I'm going to upload it over here. So let's see on the screen. So this one is Arduino code we were using over there. So that same Arduino code we are going to use it. So now you, if you, yes, you are able to see screen. In the screen, the same code we are using it over here that we have copied from the Remote XY website. Now we have to go to the tool. So I'm going to select that board over here. That is Arduino Uno. So you will find it the top. Yes, this one is Arduino Uno. So this one board I have selected it. After selecting that board, we have to select port in the tool. Port is COM10, and we have selected it, and after that we have to upload it. So we are going to upload it. So it will ask about saving it. I'm not going to save it, and I'm going to upload that code in the hardware. And now my code get uploaded in my hardware. So uploading is done. You can see in the screen, uploading is done. So after as your code get uploaded and uploading is being done, now you have to connect Bluetooth, and Bluetooth is already connected, and this one is blinking. So what we have to do, we have to follow other steps. So what is other steps over there in that Remote XY? Okay, let it come over here. So in that Remote XY app screen, if you are able to see it, let me share it again. screen. So this one is remote XY. So in the remote XY, you have to follow all other steps. So first one, what we did, we have downloaded the source code or copied that source code, then install that remote XY library, then connected Bluetooth module. Now what we have to do, install remote XY app. So that app you have to install it. So now what I'm going to do, I'm going to install that app and I'm going to control this AC bulb using my mobile app. So I'm just sharing my mobile screen over here. Okay. So now I'm going to share it. Okay, so let me off my screen over here and after that I'm going to share my mobile screen. By app from the Play Store. So I'm going to open it directly. Wait for a second, I'm just sharing my mobile screen. I'm not able to share from over there. Okay, so let me directly come to over here in my camera and let me share with you that screen if you are able to see my camera. So over here, what I'm going to do, I'm going to share my screen. So first of all, you have to open your mobile app and over there you have XY app from Play Store. Okay, let me open Play Store. Yes. So in the Play Store, you have to go to over there in the Play Store. So in the Play Store, you have to search over there that remote XY. So I'm going to search over there, remote XY. So over there, you will find that app like this remote XY mobile app. So in this app, you have to click over there and you have to open that app, install it, and I'm going to open it. So by installing, and what we have on the right side at the top side, as you are going to click on the plus button, it will show like this. These features will be visible over there. First one is USB, second one is Bluetooth, and third one is BLE, Bluetooth, and Wi-Fi and Ethernet. Then cloud server. So we are going to use right now Bluetooth. So click on the Bluetooth part, and then it is saying that enable your Bluetooth. So I'm going to turn it on. So my Bluetooth is get on over here. So after that, you have to go to your mobile Bluetooth and you have to connect it. So now it is showing that one Bluetooth module that is SC05. If I'm correct, this one is SC05. So I'm going to click it over there and it is starting. And it is saying that use password. So I'm going to use my Bluetooth password. 2, 3, 4. So now you can see whatever app you have designed over there in that remote XY, that app is visible over here with the name of remote XY. So that app is visible over here. So this one app we have to use it for controlling appliance. Like if I'm going to use it, so my relay is turning on and off. So this one is also working. So I think you are able to hear that sound. So now I'm going to connect my AC appliance with my supply. So let me connect it with AC supply. So there is two wire. I'm going to connect it, and after that you will able to see that how your AC load is working. So let me it. Yes. So I have connected my AC appliance, and I'm going to check it out how it is working. Now you can see it. So what I did, I have connected this bulb with my AC supply, and this one is my mobile app. If you are able to see my camera, and now what I'm going to do, we have to click on this button. So I'm controlling another relay that is not connected, and this one is on off switch. On, off. Relay is working, but I think that is connected with another pin. Two relay is working, so we have to connect another pin. Okay. So let me change their wiring of the pin number and check that supply. This wire is not connected properly. Yes, now you can see. I'm just pressing that push button over there at the top. This one is push button. I'm going to press it. Light is on, off. So this one is my AC light. On, off, on, off, on, off. You can control your appliance up to 100 meters. Use up to 10 meters, sorry, up to 10 meter using this. Again, all these things I'm repeating it. So I have just used one relay module with this hardware, and how I made a connection, that also I will show you using Bluetooth module. And now I'm sharing my screen. So what setup I did it, what I have installed over there. So all these 6 steps you have to follow it. First one, download the source code. I just downloaded my source code, and after that install that Remote XY app. That I have installed it in my mobile. So this one you have to, sorry, this one is install library. You can download it and you can install it in the Arduino board. And after that use Bluetooth module for connecting it. So I connected my Bluetooth module with the Arduino, and after that installed that mobile app in my phone, that is Remote XY app, and then we have to connect it, nothing else. So if you sometime if you face any difficulty, so you can find some example also over here. In the example, you will find all the detailed tutorial about this one, first project of turning light on and off. So you will find all the detailed tutorial with this, how you have to design your mobile app easily. So you can see it over here. So now this one you can do it easily for controlling that appliance. If you want to monitor any appliance data, that also you can monitor it. For that we are going to use that cloud applications. So now this one is basic. I'm coming back to the editor, and now I'm going to discuss some more advanced application of using this Remote XY. So the best advantage of this tool is that no need to write any single line of code, and you can make your customized mobile app easily, and you can control your home appliance or any industrial appliance also using this tool. Now we are going in an editor, and we are going to work on some more projects over here. So over here you can see, first of all, we are going to in a configurations, and there is one mode over here. This one is Bluetooth. Now we are going to connect Arduino with a Wi-Fi. That also we can connect it with Wi-Fi. So as we are going to connect with Wi-Fi, so over there we can use internet, or without internet also we can make some applications. So that also you can make it. So I'm just quickly showing you that how you can connect it with a Wi-Fi or with a cloud. So there is option over here, that is cloud server, that you can use it, and on the cloud control your home appliance from any remote area using internet. Internet is required with the Arduino board and with your mobile. So you can go anywhere and you can control your appliance. Like if you want to control your solar water pump using that cloud server, so that also you can control it. and from any remote area using that cloud server. So all the step will be same, just you have to set up it, and over there you have to select Wi-Fi module. So this one module you have to use it and you can apply it. To make software to hardware, if you are going to connect directly with the TX and RX pin, and these are SSID, that is your Wi-Fi name and your Wi-Fi password, that you can use it easily. So this one is for controlling applications, controlling appliance. Now I'm discussing another cloud that is for monitoring also, and you can generate trigger and alert also. So let me go to that cloud with the name of CAYE, Sane Cloud. So this one cloud, I'm going to use it for monitoring appliance and generating trigger and alert also. So let's see how you can generate the trigger and alert. So in this cloud, I'm going to just do login over there, and we can set up it and we can generate trigger and alert also. And I'm just going to make it a little bit quicker so that we can do it in a minimum time. So for that, I'm going to use one Arduino Uno plus Wi-Fi module that I'm going to connect it. So you can just login it over there, and you can, after doing login, you will able to build your application on the cloud. This one is a cloud for monitoring. Some participant was asking that how we can monitor data. For monitoring data on the cloud, we can use this cloud. This one is also open source. So whatever tool I told you, all the tools are open source. So over there, you will find different boards, like this one is Arduino Uno, port meter switch, and many device connected over there. So this one is a crop stress analysis project for agriculture application. Like if you want to do irrigation in your crop based on their stress on that their leaf, so you can make some application using like this, and you can schedule it and trigger it also. Like when water is required, you can set alert also over there. So all the data is being get saved on this cloud, and that data you can utilize it for further analysis, like machine learning, deep learning, if you want to implement. So that data you can use it over there. So right now there is no data, so that's why it's showing nothing over here. Now I'm going in a live over here again, live data. And if you want to set up that cloud, so how you can set up it for the beginner? So you can click on add new device and widget, and over there you can select Arduino Uno board. Over there you can select Arduino Uno board. So I'm going to click on Arduino. So after that you have to do next. Then after that you have to select Arduino board, that is Arduino Uno. So very easily you can set up it Arduino Uno. I'm going to select Wi-Fi module with the Arduino. So all this step, if you are facing any difficulty, because I'm doing it a little bit faster, so I will share with you one YouTube link also, my YouTube channel link. Over there you will find in a detail. So no need to worry about it. So I'm just going to copy this code. Code will generate it automatically. So after making copy this code, you can go to the Arduino, and in the Arduino, what you can do, you can open new window, and over there you can paste it. So over here, I'm going to upload this code. So before uploading, few modification you have to do. Over there, you have to name your SSID, that is hotspot name or available Wi-Fi network. So that I'm going to use it. So after putting that name, so name of my hotspot, I'm just entering it. And password also over there, you have to insert it. So my hotspot password. And after that, few more modification you have to do it. Serial one. So this one you have to remove it. So only few 3 and 4 modification you have to do it. And I'm doing it little bit quicker and faster. So you can make it sign out default. Sorry, you have to remove that default. because we are sending data on channel 1, channel 0. And after that, you can verify this code and you can upload this code in the hardware. So how you can upload that code? So I'm going to use one Arduino plus Wi-Fi module right now that is having near to me. So over there, I'm going to upload that code. So how we can upload that code over there? I'm just going to show that how you can upload that code. So wait for a second. So you can see that Wi-Fi module that we are using it over here. So you can see over here in the camera if you're able to see it. So this one is Arduino Uno plus Wi-Fi module that I'm going to use. This one is same board. We were using that Wi-Fi module over here in the PPT if you're able to see it. So now we are using over here this module. This module is equivalent to this. So for avoiding these connections, I'm using this module directly. So either you can use this one also, you can I'm going to upload that code and I'm going to send data to the cloud. So let me just upload that code over there. So there is some DIP switch. You have to change their mode for uploading code and connecting it with the Wi-Fi. So how you can use it so that you can see it like this. So I'm just turning on 1 and 3 and 4 pins should be on when we are uploading code, and all other pins should be off. So I'm going to connect it. So now I'm going to connect my board with my USB, and I'm going to connect my USB with my computer. So after connecting it, so power is not coming. Yes, power is coming in my board. So there is some loose connection in my USB. Yes, now it is working. So you can see power is coming in my board. So after that, whatever code we have generated over there, that code we have to upload it in the hardware. So how we can upload that code? We have to go to the Arduino board. So this one is my sketch over here in the Arduino. So that sketch, I'm going to use it. So go to the tool, home port is coming 10. Again, you can check home port 10, and now you can upload that code. So I'm going to upload that code on the hardware. So this code, I'm going to upload it right now in my hardware. Yes, the code is uploading. After uploading that code, uploading is done. I'm just going to turn on 1 and 2 pin for connecting it with the Wi-Fi. So let me connect it. So 1 and 2 pin, I'm going to connect it. Yes. So after that, we have to turn on that mobile hotspot. So I'm going to turn it on, that mobile hotspot. Yes. And going to check that how many devices connected. Yes, there is no device connected yet. Yes, my Wi-Fi module is get connected with my hotspot. Now, what you can do, you can go to that cloud and you can see data is coming or not over there. So this one we did it, done it. And now you can, it is showing waiting for the board. So wait for some time, and after that, yes, now you can see your data will start coming on the cloud from that Arduino board. So right now I have not connected any sensor with this board. So as I will connect any sensor, so this one will be the dummy data will come over there on the cloud like this one. So this one is a dummy data, that is internal data, internal timer that is coming. So a lot of modification you can do it and you can use it. So due to the time limitation, I'm just directly sharing with you that tutorial on the YouTube. You can use the tutorial for learning it. So this one is my YouTube channel, and over there you will find all the detailed tutorials about this Wi-Fi module. This one is a detailed tutorial, so you can find it, condition monitoring of a machine using that Wi-Fi module. So that link I'm just sharing with you. And now I'm just coming for question answer. If any participant having any kind of queries, any kind of doubt, they can ask over here in the chat box. Yes, you can also subscribe that YouTube channel for getting latest update, because few more tutorial we are going to update it over there. So now coming back to question and answer. So if any participant having any kind of queries, any kind of question, they can ask over here. Yes, any participant having any kind of queries, any kind of doubt, they can ask over here.
Yes, participants can ask any questions, or you can put in the chat box. Mr. Ajay Kumar,
Yes, sir.
because this IoT or technical applications are very much there in the manufacturing, real estate, even the retails. But why much inroads has not been made in the agriculture sector? I think it is far behind than other sectors. Looking to the utility benefits, either our farmers are not in a positions, or the government, state governments are not taking proper steps to educate them properly, or not making much efforts to introduce technology, because there is a lot of benefits so far technology is concerned, if it is properly makes its inroads, or it is there in the agriculture sector. It's a vast sector. Or say,
Correct. The
uh,
draft order.
hmm.
Yes, one of the major drawback is that with this one technology is little bit costly. When we talk about farmer, it's not affordable, the ready to use technology. But you know, we have to work out over there for making it affordable. So that is one point, and second point is that farmers are not familiar with the technology. Sometimes they are installing it, but after that, when we talk about maintenance and usability, so that is little bit tough for the farmers. So a lot of step is required to taken by the government. So government is working over there, but in upcoming 4 to 5 years, you will able to see the results on the ground.
On the ground, yeah. Because you people keeps on going and visiting many, universities relating to the agriculture sector. At least you can take people like you can take up such issues very seriously, so that this tomorrow's technologies become more affordable. Say in European countries and in particularly in US, Australia. See, that's because the fields are very big. There is a
Yes, sir.
different type of technology, but here what is there after this in our agriculture lands, it is very much segmented, holding is very less. So now big tractors, how a big tractors can be used in a small homes. So we should think that a small tractors is more affordable, so more usable for a small type of holding. Here land holding of at least 70-80% people are having less than 1 acre.
Right, sir. Right.
That is all these things, and therefore technology has to be attuned with the requirements of the land.
True, sir. So, you know, that is a lot of work is going on, and very important point is that educational institute has to work on that
Yes,
domain,
yes.
so that
Work on
directly
this,
they can
yes.
link with the farmer.
Yes,
Because
yes.
a very important point is that when we talk about integration of education institute with the industry, that is not easy.
Not easy. Yeah.
Yes, but they directly can link with the farmers. So whatever they are
Yes.
building it, they test it and they can deploy it.
But in the meantime, say pesticides. People in Punjab now, even in Haryana, people are being affected because of these pesticides. One trains from Punjab, which is called a cancer train, goes to
Right.
Bombay. So at least technology at this level can be introduced. What type of nature of pesticide should be used for cultivation of crops?
Right, sir. So that is highly required, because with the
Highly
help
required.
of that government
Yeah.
also can monitor farms and their field using
Yes, yes.
IoT. Like
Yes.
recently, I'm just sharing with you one example. So
Mm.
recently, government has launched one scheme, that is Kusum Yojana. So with the help of that, they are installing solar water pump. So what
Yeah.
they are doing, they are monitoring all the solar water pump in a real time. So all the data is going to the government.
Mm.
So, because the government sometime what is happening, what they are implementing, that real scheme is not implemented on the ground. So now they are monitoring it using IoT, so that they can check real status that that pump is working or not,
Or not.
and that is installed or not.
Mm. So much initiative is also not from the government side. That is the whole problem.
Yes, sir. Yes. So we
Yes.
can't do over there, but we can do
Yes,
for
sir.
from our side. So that we
From
have to
our
do.
side, yes, 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 yes. That is right. So my this faculty members, any doubts, any queries, any questions is there? Sir is available. Though time is already there, but still you can raise one or two questions. Mr. Ajay Kumar Godra, you wait for another 2, 3, 4 minutes because we want to honor you with some certificates and a memento. You stay for a
Sir,
few more minutes.
I will join it later on in any other session, because right now I'm having one another session at 11:30. So really sorry for that.
Yeah. So is all right, sir. All right. You'll be busy with
So,
your engagement. But otherwise, it
right.
has, is already come, sir.
Okay, sir, you can do it. You can do it. Go ahead.
Yes, 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 yes. Is a token of remembrance, token of love from Shankar Institute of Technology. Okay, sir.
Thank you, sir. Thank you so much.
Yeah,
Thank you so much, sir.
yeah. And this certificate of appreciations for your nice talks, nice deliberations, very educative, very informative, and very practical applications of many agriculture type of devices.
Thank you, sir. Thank you so much for great
Yes,
honor.
yes.
So thank you, sir. I'm
Sir,
just
sir.
I have to
Yes,
leave now.
yes, 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 yes. Thank you very much, sir. We again express thanks to you. Yeah. Is over? Well, participant, next session will start as usual at 12:30. Thank you very much. Meantime, we are breaking for about 1 hour.
Hello.
So, Srikant?
Yeah, sir. I'm there, sir. Hello, sir.
Sir.
Before we commence our sessions,
Yeah.
our
Yeah, I'm ready. Not a problem. I'm ready, sir. I'm ready.
yes, before you the sessions, yes, before you start the sessions, our chairman, sir, Dr. S, with his sounding.
Yeah.
Good morning, everybody.
Yes, sir.
Sure,
Over to you.
sure, sir. Not a problem.
Yeah. Good morning, everybody. And especially, I welcome Dr. Venkat Srikantji,
Yeah.
who is the joint director.
Yes.
Yeah.
Thank you, sir.
I'm welcoming this our today's greatest speaker, Dr. Venkat Srikantji. He is the joint director, CDEP. Sir, and Rajasthan Technical University, both are very grateful to you that you have spared your valuable time. I understand that you are so busy, but with our small request, you have accepted our invitation. And I heard from participant, they were appreciating like anything your words, your description, your lecture was excellent. It's
Thank you, sir.
unforgettable. So we all are grateful to you, and we hope your vast experience, your knowledge will help our faculty student in future also. And
Sure, sure.
tomorrow is our valedictory session. So I know you are so busy, but if there is any possibility, I'm requesting you between 2 to 3, our valedictory session is fixed. So
Okay.
if you are sparing few minutes, Sankara family will be grateful for your presence. And on behalf of Rajasthan Technical University and Shankara Group of Institution, I'm requesting you to spare few minutes tomorrow at 2 p.m. also. And in future, whenever time will be for Shankara and for RTU, I am expecting always your gracious presence with your word, and Shankara is on your disposal for anything, for any type of this support, whatever is possible from Shankara side. I assure you, sir, forever we are on your disposal. Once again, thank you very much for your valuable time that you are sparing for Shankara and for RTU. Thank you very much.
You're welcome, sir. Thank you very much, sir. Thank you. Yeah. Sir, shall I?
Extending your warm. Yes, sir. Now over to Srikant.
Yeah.
Your
Thank you,
topic,
sir.
sir, is IoT idea to prototype to product. Yeah. Yes. Carry on, sir. All the
Yes.
best.
Yeah. Thank you. Thank you very much, sir. Is the screen visible, sir?
Yes, sir. It is
Yeah.
visible, sir.
Huh,
It
sir,
is visible.
it is visible, sir.
Yeah. Thank you. Thank you. I'll start my session. Yeah. Good afternoon, everyone. I think in my last session, I have covered the architectures of IoT. What is an IoT? What exactly is IoT? What are the components of IoT? What are the examples of IoT? What are the case studies of IoT? Now, what I'll do is we'll take up an idea. Before you all, I'll take up an idea and try to develop a prototype of it. Okay. Generally, what generally happens is, as engineers, we all directly jump to take up an idea and try to develop a product. But the problem is, you take up IoT, you take up any domain, in the area of embedded systems or electronics and all, it is very costly if there are any problems in the final product. So what we generally do is, first we try to do something called as a prototype basically. Okay, that is nothing but a proof of concept. So any changes needed in that proof of concept will be very easy for doing than changing it at a later point of time. So we'll be discussing and what are the different various steps we generally follow to make a prototype, that I'll be clearly telling you in terms of IoT basically. Okay, so let me start off this session. So the thing is, so my session would be something like this. What I'll do is, we'll try to take up 5 W's and 1 H. So what are these 5 W's and 1 H's? See, what is the intended outcome of this session? Why we should do this sort of a something called as a prototyping. Who is the end user? Where will be the deployments? And when we can complete a prototype? And how will we do it? All these questions will be answered in this session, which is a technical session on an idea to a prototype. I call it as an IPP model, that is idea to a prototype to a product. Okay, an idea will lead to a prototype and a prototype will lead to a product basically. Okay, that is why I'm talking about this session. Okay, let me start off with this. So the thing is, if you look at, so the first question is what is the intended outcome of this session? So we are very clear that at the end of this session, we should be able to develop a IoT prototype. Okay, when we want to develop an IoT prototype, so able to build a prototype of an idea. That means we need to take up an idea and based on that idea, we'll develop a prototype basically. But the question is, can every idea become a prototype, or can every idea IoT can solve? That we need to look at basically, because there will be different problem statements. But all problem statements can IoT solve, or we are just jumping into it? That also we need to look at, because IoT can't solve all the problems. But one thing is, IoT is already there in a lot of domains basically. But still, I would suggest that we need to first look at, just because we know IoT, we need not jump into developing an IoT prototype just because we have an idea. The first thing what we need to look at is whether we have an idea, whether it's already there in the market, then why we are developing it. So all these questions we need to take up in a series of steps basically. That is what I'm going to tell to you guys today. Okay. So the thing is, what is the intended outcome of this session? I should be able to build a prototype of my idea at the end of this session. Okay. So the thing is, if we look at the same thing is, the first thing is, before jumping into anything, the first thing is we need to have an awareness of all the technological aspects of the latest products in the IoT market. The thing is, we need to have a complete awareness. We need to do some homework basically, because I got an idea to develop. Let us think I want to make a IoT fan, but already there are a lot of people who are developing an IoT fan. I want to develop an IoT bulb, but there are already a lot of products in the market. Then why should I do it? So that is the reason I should have awareness of all the products in the market. And I should look at which domain I'm jumping into. Then identify the abstractions. There will be a lot of ideas available in the market, but they may not be coming up as products in the market. Can I jump into it and build some novelty into it and develop some solution for it? I need to look at basically. So we are still at the homework stage only. Okay, we didn't jump into the session yet. Okay, always keep that in mind. And one more thing is awareness of available components to choose for your product. Yes, what are the components I need for my product? See, I'm saying that IoT will solve my product. IoT will solve my problem. So what are the components I need? Yesterday we were very clear that we needed sensors, we needed connectivity, we needed people in the process. So what are those components? I need to have a complete awareness before jumping into my thing basically. So that is what I need to keep in mind. Okay. So once I look at all this, what I'll do is, so now I'll start experimenting on different ways basically. So what I'll start experimenting is, so the next question I would love to answer is why? Why do you need a prototype at all? Why can't I, when I have awareness of all the components available in the market, why can't I directly jump to a product? Why should I need a prototype? So the question for this is, so this is a very famous diagram available in all the IT market. So everywhere you go to any software engineer, they have a clear picture of this. The problem is, you see this diagram, what is happening? The problem is, if you look at, is any product you take in the market, when a customer explains, he'll explain like this as step 1. So a customer has explained like this. So what a project leader understood, project leader in the project, a client explained him like this as step 1. Then a project leader who listened to him, okay, a client wants this. So he thought that I should develop something, a swing like this. Then an engineer, he went to his engineers and told that you have to develop something like this. So an engineer has designed like this. Then what did happen is, a programmer, he has written his code like this. I think we all know what the best code we write basically. Then when it goes to the sales, they describe that our product is like this. But what happened when the project got documented, it was something looking like step 6. Then when our operations and maintenance team, when they go and deploy it, it looks like step 7. Then how the customer was built was step 8. And how the help desk supported is was step 9. Then if you look at the step 10, the customer really wanted that. So where is the problem? The problem is simply we listen and we come and we develop, we directly jump developing a product basically. That is why what they say is you need to have clear requirements. Because that is why what they say is when you develop a proof of concept or a prototype, then the customer will understand, okay, whether we are going in the right direction or we are going in the wrong direction. Saying was showing always is very important basically. That is the reason we have to develop a prototype first. Always remember that. So if you look at the thing is communication was the problem. So proper requirement should be gathered first. That is very clear. And you show him step by step. If any changes are there, if you're at a prototype stage, you can again revert back. But if you are going to a product, it is at the final stage, you are making changes, it is very costly. Fall early and rise early. That is what very clear in this concept basically. Always. So the thing is, if you look at the thing is, so what are the advantages we have with the proof of concept is, will be technically it's possible or not, because a lot of people have a lot of ideas basically. Yesterday someone was asking, can we prevent corona? Can we prevent corona? Yes, I think you can avoid a person to get into the norms of corona, but we can't prevent corona with IoT. That is what we need to do. So technically it's possible or not. That's an idea basically you have. So a lot of people are developing some watches where you can avoid people who are nearby you who are having corona basically. But really IoT can't solve corona basically. Am I right? So a lot of people have a lot of ideas. But if it is a POC, whether it's technically possible or not, we need to look at basically. So that is the first thing which is helping us to when we are developing a prototype. The second thing is usability testing. When we go to usability testing, the thing is advantage we have is, so any unforeseen or unimaginable test cases are there. Like for example, we didn't see while developing a prototype that all those things can be put up in that basically. So when we are developing a product, we'll be seeing all the challenges. As I clearly told you that about our garbage bin, what happened? The lab, everything was working fine. When I went outside, nothing was working because temperature was playing its role, air was playing its role, light was playing its role, everything was playing its role. Then we realized that we need to go for a cone-shaped ultrasonic sensor basically. So that is what we need to look at basically all this. And fail early and inexpensively. That is very clear. And progressing, we can show a customer that the work is getting progressed basically. Working getting progress. And as I clearly told you that final system design, when you develop your product, you will have all these challenges put into that. So that makes you a very big, very clear project. So your product will not fail in that case. So that is the reason we need to have a prototype at first. Always clear. Okay. The thing is, now what do we learn today basically? The learning concept, as I clearly told you, is we are going to develop something called as rapid prototyping. See, till now people were saying about prototyping, but I'm going to teach you something called rapid prototyping. Rapid prototyping is within days, within 1 week, within 10 days, you should be able to develop a prototype. Previously, people used to take time like 1 month or 2 months for developing a prototype. But now we are in the era of rapid prototyping where you need to do it in days, like 3 days, 4 days, or 1 week, or 10 days basically. So that is what we are going to learn today. Okay. The thing is, if you look at thing is, how do we do it is, we are going to take up an idea and develop a prototype with a series of steps. So what are those series of steps we are going to look at basically? Okay. The series of steps, if we look at is, the series of steps is, before jumping to the steps all, I'll be teaching you step 0, step 1, step 2, step 3, step 4, and step 5 today. Okay, in a technical way. So, but before jumping to that, we have to do something called as a context. Context is nothing but why I am taking up IoT today. Will IoT solve my problem? That is what I need to look at. Or as I clearly told you that we should have awareness of all the technological products available in the market related to IoT and different domains also. For example, I want to make a wearable like a watch, but watches are so many are there in the market. What is the added advantage I'm giving? Okay, if I want to still develop it, what are the components required? and all these things I need to study it in context basically. So that is why we say it as IoT technology and verticals. That is the context. So when I get into the context, so I'll be taking up 3 things in that. What is that in context? First thing what I'll do is look at the various IoT products across the verticals. See, I have an idea. It's already there in the market. And why should I do it? Or are you building any novelty into that? Are you building an additional functionality so that that's more effective? So that we need to look at basically. Then what is the IoT infrastructure? Already we have seen it yesterday. So the IoT infrastructure requires sensors, connectivity, people, and the processes. So are we prepared for that? And the third component I need to look at is where can we apply my idea? Is it falling into any domain? Like is it the health domain or wearable domain? Sorry, wearable domains, health domains, or city domain, or environment domain? Where it is falling? I need to look at this. So this is the first homework I'll do before jumping to the steps. Okay. So the thing is, let me to look at in the context. I'll be looking at the IoT products and verticals basically. When I go into IoT products and verticals, so there are so many verticals are there. Consumer is there, medical is there, smart buildings are there, utilities are there, smart city is there, smart agriculture is there, environment, logistics, industrial, and many more. Like sports is there, defense is there. So many areas are there. Where will my idea fit into? And one more thing is already so many applications are there in the market. Why can't I reuse them? Should I start develop from scratch? All that, yeah. So all that I need to look at basically. So all that, all these applications and all, I need to have a bit. I need to look at so that I'll understand that okay, my idea is fitting into these domains, and there is no such application in the market basically. So that is what I'll have a clear picture of the IoT technology. Once I have a clear picture of this IoT technology, then what will I do is I'll look at the infrastructure required for IoT now. So what is the infrastructure required for IoT? So as we are very clear, IoT technology consists of 3 components. That is what we thought of yesterday. That is sensors, connectivity, people in the process. If your application requires actuator, you need to put up an actuator. Okay. So this is what is IoT technology talking about. Sensors are the input, connectivity is the medium, and the people in the process are the data coming out of the cloud getting processed and given to the respective stakeholders basically. So that is what we need to look at. So are we prepared for that? Are we prepared if we think that our idea has to be solved with IoT? Are we prepared for this? So once I am prepared for this, once I come to know that this is the infrastructure which is required, then I'll decrypt it further. Because I'm an electronics engineer, I'm an embedded engineer, I should know that these are the things which are required. So what do I require? I need sensors based on the application. I need a controller to interface these sensors because controller is the one which processes. I need a communication interface which can send the data to the cloud. That is a medium I need. If required, I need a gateway in the middle. If required, I need a gateway in the middle. If I think I need because I can't have much range for my IoT nodes, I need a range component, that is a gateway in the middle. From the gateway, the data will go to the cloud. If not, your communication interface should directly send it to the cloud if it's a standalone device. So that is what I need to look at. Once the data comes to the cloud, I know that it is processed. The data is visible on the dashboard, either the dashboard. From that, it can go to mobile applications today because people are talking about mobile apps. Various mobile apps are there on that. And apart from that, as I clearly told you that if required, we need to go for voice user interface because a customer may say, I need to just tell and the work should be done. Then you need to add these assistants like Google Home Assistant, Alexa, and so basically. Okay, these are the various components I need to keep in mind. Okay, so if my idea has to be built into a prototype, all these things are needed. That is very clear. Okay, have that in mind. So once I have that in mind, what will I do now? What will I do next? So I'll divide that into 3 parts now. So I need a hardware, I need cloud infrastructure, I need a software. So in the hardware, what do I need? I need a controller or a processor, whatever you say, required circuitry, sensors for the application, actuators if needed, and networking link. Networking link is nothing but a communication basically. Communication. Then on the cloud, what do I need? I need 2 components. One is the server component and one is the user interface component. User interface component is nothing but the dashboard basically. And the final thing is to run these applications, to write these applications, I need to have a software basically, right? I need to have software. So then I need to look at if I need OS or not. If I need OS or not. If I need OS, so what is the OS I need? And if I need application, what is the application? I need to write the application for basically. So because generally what happens is embedded systems and all, sometimes they run on firmware. If you think there are more tasks, you need to put an operating system basically. So that is what I need to look at basically. So this is what I'll keep in mind. Okay, these are the three components I need. Okay, so once I think of these three components I need, then what will I do is I'll look at my idea basically. So what is the idea I want to develop today? Can IoT solve this? So for demonstration, for telling you guys, I have taken up an idea called as animal tracer basically. Animal tracer is nothing but a small IoT device put on a pet animal. For example, we can put it on a dog or a cat or anything. I just put it as dog. So we are going to develop this band today. We are going to develop a band today, and we need to show the data coming onto the cloud. Okay, all that we'll be doing today basically. So through a series of steps, which I'm going to tell you now. Okay, so an IoT device for an animal, that is the idea I'm taking up. Okay, when I take up that idea, now what I need to do is this completes my context component. That is what I would say before jumping to my idea, I have completed this. So I have taken up an idea called animal tracer now. So how do I implement that through a series of steps that we'll see today? I have to take up this idea to develop a rapid prototype. Okay. So the thing is now, that is what. So this completes my context. When I complete my context, now what I'll do is I'll jump to step 0 basically. What is that step 0? Step 0 is first I need to see idea is animal tracer. Whether it's feasible in the market or just jumping. Already there are products in the market, then why I am doing it? So I need to do something called, are there any real problems or I am creating the problems? So I need to have a clear problem statements so that can be converted to a solution. Always clear, be very clear. Then only that product will be selling in the market. Are there any users for buying it? All that what I do is I do in step 0 basically. Step 0. If I don't want to take up animal tracer, I'll stop it. What happens? When I stop it, I haven't still wasted money yet. I have only wasted some time in exploring. If the idea is not good, I'll stop it here only at step 0. If I really like the idea and people are accepting that idea, people are there to buy that idea, then I'll go to step 1, where you have to start investing some money basically and time. Till here, I have only invested time, not money yet. So when I go to step 1 will be selection of various processes basically available in the market. IoT market, what are the latest SOCs available in the market and all. I'll be checking to select my development board. That I'll do in step 1, because today I am doing something called as a rapid prototyping. When I'm doing something called rapid prototyping, what is happening? What is happening is I can't develop my own board, a PCB, I put my chip and all. That will take time. Well, at this point of time, we all have something called development boards available in the market, where everything is there on the board. You can directly select them and use them and prove your concept basically to show someone. So that is what we are going to do today. So that is step 1, what I'm going to do. Then I go to step 2. What is step 2? Step 2, what I'll do is, see, till now you have developed, taken the development board. But what is your application? What are the sensors? Do we need an actuator? And what is the communication? Is it a standalone or you're going to put a gateway in the middle? Everything I am going to do it in step 2 basically. In step 3, what I'll do? Step 3, what I'll do is I'll take up the cloud component, because we need to show the data onto the cloud. Because we have to show the data onto the cloud, the data has to come onto the cloud, so it has to be processed. So I'll go to step 3 basically. Okay, step 3. Then what I'll do is step 3. Then I'll go to step 4. In step 4, what happens is, see, all these components which are there, the sensors, actuators, networking link, and all have to be integrated. I have to write a program basically, so that I have to push the data onto the cloud. So for that, I'll go to step 4. And finally, I'll see the challenges which are there in developing a prototype basically, and try to address those challenges so that I can develop a product. Okay. Now let's go to step 0. Yeah. So what I'll do in step 0, as I clearly told you that it's ideation and validation. So when I say it's ideation and validation, so what is the thing we are going to do is, we're going to address three things here. So what are the problems in the market? What are the problems in the market, and what are the solutions for those problems? What are the solutions for those problems? And we need to validate whether this is going to solve it or not. The first thing is whether your problem is going to solved by IoT or not. We need to look here basically. Okay, that is what we call it as ideation and validation. So the thing is, first, problems. So what do we do? How do we get the problems? I clearly told you that we get the problems when we go to various users or customers, and so basically we get the problems. Okay, just sitting in the lab, you may be thinking something, but in reality there will be something basically. Okay, just for an example, I'm telling you, when we developed our garbage bin module yesterday, I was showing you, the thing is, sitting in the lab, I was thinking that only fill level is enough. But when I went to our municipal corporation, that is GHMC, Greater Hyderabad Municipal Corporation, they were suggesting that, okay, sir, this problem is there, but we have some other problem. Like foul smell is one problem. Based on that only, we added the foul smell. They said fire is a problem. Based on that only, we added temperature sensor. So all these requirements, when you go to the customers, you'll get. Sitting in the lab and doing, you will be restricted to your own requirements basically. Always remember that. So how do we solve them is we have to apply technology to solve them. So for that, what we are going to do is, so now we go to various customers and what do you say? Collect the problems basically. When you collected the problem, so some of the problems which I could collect for this animal tracer is, because my idea is animal tracer, am I right? So what are the things I could find is, see some problems which I could see is many dogs suffer from noise anxiety. Whenever there is a noise, a dog runs away. I want to track it. Whenever a dog goes missing, every second counts. You should be extra careful when you're taking a dog while traveling. And dogs generally look at cats and all, they run behind them. Dog napping, because you know that pet animals are very costly today. Even stealing of these pet animals is very critical today. And changes in activity can indicate illness. That means dog is not moving at all and it's sitting at some place. That means there's some problem with the dog. So these are the various problems I could collect basically from different users. These are the various problems. So if you look at the problems, you see problem number 1, problem number 2, 3, 4, and 5. All these 5 statements are telling that we need to track a dog. So we need to keep that in mind. Okay, this relates to tracking. Then what is the sensor I have to use? That will come to the later stage, but just keep that in mind. Okay, so okay, tracking enter. And the 6th point which is there, which indicates illness. That means I need to even add health also. That means I need to add 2 things. One is what? One is the health, one is tracking. These are 2 components I need to put in my IoT device now. Okay, very clear. So once I think like that, once I see the problem statements, then what I'll do, I need to look for the solution. So what is the solution? What is the solution? The solution is I need to have a wearable device for my dog. A wearable device which is on the body, on the dog's body, so that I can have 2 components. One is tracking and one is health monitoring. That means a dog should wear something where we can find something called the location of the dog, the health status of the dog, like the heart rate, activity, and all. All this data should go to the dashboard of the owner basically. And apart from that, one more component we can add is that that no one has told, but one more component we can add is that is called in contact. What is that in contact? In contact is we need to put a touch sensor to know that wearable is there on the body of the dog. The problem is, see, any thief who's there, he'll not carry even the wearable. He may throw the wearable there in your house and he can run away with the dog. Then you will still think that the dog is within your house. Right or wrong? So we have to put something which gives a signature of the body of the dog. That means it's touching the dog. So for that, we have added one more sensor, which is called in contact, basically. In contact. Okay. So these are the 3 things we need to put up in the wearable basically. So we are very clear that now our idea is wearable device for dogs. Very clear. So once we are done with that, and now what we need to do is, now we need to validate it. Validate it is we need to push up a lot of questions, whether already there are products in the market or your product is adding some value. Do you think a lot of people are going to buy it? Who is going to pay? Business model and all these things we need to calculate basically before developing a prototype. Because without jumping, because as I clearly told you that this is the last stage where from where you are going to start investing money. Till now you haven't invested money. Be very clear. Okay. So once you are done with that, you have to push up a lot of questions like this, validate yourself, and finally freeze whether you are going to execute this idea or not. So now I feel that let me go ahead with this, because a lot of people, there is a requirement of this. And one more thing is, we be very clear that if you are getting this sort of an idea, then a lot of people may be getting the same idea. Don't think that you are the only one who is getting this idea. Okay, so different people, different ideas, different solutions basically. Okay, so that is what, whether our solution is cost effective or not. All these points I'll validate once I am done. So now what I'll do is, we are going to move ahead with this. Step 0 is done. Step 0 is done. We are going to move ahead with this. So once we are moving ahead with this, now we are going for the wearable device for the dogs. So once we are going with the wearable device for the dogs, so what I'll do is, my step 0 is done. Once I'm done with step 0, now I'll go to step 1. Now I'll go to step 1, because I am freezing my idea. I have ideated and validated, telling that I'm going to go ahead with that animal tracer, which is nothing but a wearable device for the dogs. So now I'll get into more technical basically. Now I'll go to step 1. So when I go to step 1, what is happening? What thing is, now I'll get into the hardware. What is the hardware which is required to make a IoT prototype? So the thing is, as I clearly told you, the first component is selection of a processor. Sir, what is the controller required? Because controller and all are required to interface your sensors. So what is the required circuit you need? So for that, what I'll do is, because which domain are we in now? We are in the wearable market domain, am I right? Because we are in the wearable market domain, what I need to do is, I need to look for the latest SOCs available in the market, because the two for wearable. Why? Because I can't get biased into some outdated SOCs basically, because every day new SOCs are coming in the market. Especially you take up ARM, so many chips are coming into the market basically today. So I need to, that too, they have segregated into different domains also. Like for wearable, you can use these chips. For utilities, you can use this. For garbage, you can use this. For this and that, you can use for X number of applications. You can all use all this. So first, I need to look at the latest SOCs available. Okay, for wearable market, what are the latest SOCs? Can I use them directly, or are there any better ones in the market? So that all that I know. So based on those SOCs, I'll freeze some SOC, because I'm not going to, because I'm doing something called rapid prototyping today. Because I'm doing rapid prototyping today, I'm not going to develop my board. I have to use some development board based on that SOC. Are there any existing development board in the market? Just like your Arduino or something, any development board is there in the market with the same SOC which I am freezing on. If they are there, take it up and develop your solutions. So that is what we are going to look at. So these are the 3 steps which are going to go. Okay. So what I'll do is, first thing is, before jumping into any development board, your development board should have a picture like this. Your development board should have a picture like this, and it should be post-mortem, so that it has different things like. So your development board should have a picture like this basically, so that you will get a clear picture that what are the interfaces available, so that you can select your sensors based on that. Because I have some 3 or 4 SPIs. Sensors are 3 or 4 SPIs, but so many SPIs are not there. I2Cs are not there and all. I need to have a clear picture basically of the development board which I'm going to select. So anything you should have a picture like this. Always be very clear. So this is just a sample I have put for you guys. This is not the board which I have selected. Please be very clear. I'm going to select my board. So this is just a picture I am put, so that you guys get a clear picture of how we need to select a development board. If I'm freezing a development board, I need to check at each and every component. How many interfaces are there? What are the communication protocols it's supporting? And all these things basically. So whether it has Ethernet, it doesn't have Ethernet, it has Wi-Fi, it doesn't have Wi-Fi, what is there on that? And all these things I need to have a clear picture basically. Always be. Okay. So the thing is, then I'll look at the latest SOCs available in the market. So what is the domain which we have selected? We have selected wearable. Am I right? So I'll look at wearable SOCs only in the market basically, so that I'm optimizing my search. Now, always be very clear. So when I look at the latest SOCs available in the market, the first SOC I would be looking at is Apple Watch. I think Apple Watch is very famous. One of the best, I think one of the richest IoT product available in the market today. It has everything there, everything inside it. So Apple Watch. But the only thing is, if you look at Apple Watch, the internals of Apple Watch, it has ARM V7 core, 512 MB RAM, GPU is there, heart rate monitor is there, Wi-Fi BT is there. Do you think this sort of a SoC is needed for a dog? I don't think so. Why you need so many so high-end features for your dog? You need a simple thing which can track, which can give your health analysis, and which can give you in contact or not. Am I right or wrong? Those are three features we are planning to give. For that, this is very high thing for us. So we can't get into this. If you look at this Apple thing, so many are there. 8 GB flash is there on the SoC. So why do we need this sort of an SoC based system on chip? So this is ruled out. So we go to the next SoC available in the market. So which is Samsung Gear Exynos watch, Exynos 7270. It also, if you look at the internals of this, this is also a very high end. It is 64-bit dual core CPU based. 64-bit dual CPU, 1 GHz dual core ARM A53. This is too high end for a dog. Am I right? A wearable for a dog. And it has a GPU also. Graphical processing. Why do we need all this? Okay. So in the wearable market, this is also one of the best SoC. This is also ruled out. Okay, then we go to one more thing is the next component, next SoC, which is called as Qualcomm Snapdragon. I think Qualcomm watch, and I think is this also you see it's Cortex A7. It has a Wi-Fi, Bluetooth, and so. So these are all, if you look at all two high-end SoCs available in the market, when I'm doing a survey, okay, especially in the wearable domain. So what I'll do is now let's get into some low-end one basically. So there is one watch which is developed by an Indian company called as Hug Innovation. So they are using something called MediaTek MT2502 Aster. MT2502 Aster basically. So if you look at it as ARM 7 TDMI, one of the starting or first version of ARM basically, successful model of ARM, successful core of ARM. If you look at it has a 4 MB RAM, it has 16 MB flash. One good thing is it has GSM, Bluetooth, Wi-Fi, and all in one SoC only. So I'll keep this in mind. Okay, this is one of the, and this is especially developed for wearables only, this SoC. And it's considered to be the world's smallest SoC. So I'll look at, okay, why don't I freeze I'll keep this SoC in mind basically. Okay, I'll keep it aside. Okay, this is cheaper and let me keep it aside. I can use it for my dog or not, I'll decide. Not yet decided, I'll decide at some point of time, but I'll keep that in mind. You guys also keep that in mind. We are one of the nominations for our variable is MT2502 SoC basically. Okay, so the thing is, the next component I'll say is, till now we have seen all our ARM, advanced risk machine. But is there only, why I'm getting biased only to ARM? Because ARM is already in IoT market, ARM is very good for IoT market and embedded market, should I get biased? Or because even Intel is coming into IoT market, why don't I look at even Intel things which are available? Let's see, let's look at, so one of the Intel product, as I clearly told you yesterday, was this one, am I right? It's called as a Intel Curie module basically. When it is called as an Intel Curie module, the advantage what we have with this Intel Curie module is, just a minute, this is a small chip by Intel basically, Intel Curie module. The advantage is 384 KB of flash, 80 KB of SRAM, and it has some sensors inside that. Bluetooth is there basically. And the only thing is the processor architecture is x86. Till now, what all we have seen were all ARM architecture, but this is a x86 architecture basically. So this also I'll keep in mind. So I have now taken up two things. One is MT2502 and one is this Intel Curie module basically. So I'll keep them aside. Okay, let me now select one among them. So with these SoCs, let us look at whether we can build our applications onto this. Now what I'll do is, now problem is, as I clearly told you, that taking up SoCs, developing and all, it will take a lot of time basically. But we are, as I clearly told you, today our session, we are going to develop something called rapid prototyping. So when we are doing something called rapid prototyping, as I clearly told you that we can't build everything from scratch. We have to take up which is there and build on it. So I'll look at that, whether these SoCs are having any development boards available in the market. Development boards available in the market, yes, there are two development boards available in the market. Two development boards available. So one, luckily what happened is, MediaTek M22502 Aster has something called MediaTek Linkit 1 development board. that Intel Curie module has Intel Genuino development board. So 2 development boards we have. Luckily, we have with those SOCs, we have this development board so that we can directly work on them. Tomorrow, if we want to develop a product, I can buy these SOCs and develop my product basically, if it is feasible on this. So I'll start jumping into this, but I have to freeze only one development board. I can't freeze both the development boards. So before that, what I'll do is, see, just I'm getting biased only to this, or can I go with some other development boards available in the market? Okay, so that is what I'll just have a look at this point of time. So what I'll do is, there are hundreds of development boards available in the market, hundreds of development board, taking from your Arduino, Particle, and so. But I will have look at some development boards and see what are their pros and cons before freezing these development boards. Okay. So the thing is, what I'll do is, I'll look at the first development board. I think the most used development board in the market today is Arduino basically. The advantage with Arduino is it's a very small development board and the cost is also very less, up to from 500 to 1500 and all. But only thing is I could see is, if you want a wireless communication on this, wireless communication, what you need to do, I need to put up a shield onto it. For example, I want to use GSM, I have to put an additional shield onto it. I want to use Wi-Fi, I have to put an additional shield onto it basically. So that is the only disadvantage I could see in this. Or not, we can all develop everything in Arduino only. Okay, so an additional shield is required for this. So we need to look at if there is any board which is having already internally, that's an added advantage for us basically. So that is what I'll look at. So Arduino is one. I think Arduino is ruled out. Then I'll go to, as I clearly told you, that this is Intel Genuino, that is, it's completely based on Intel Curie module. But the problem is, if you look at the communication which is there, is it's having only Bluetooth on it. So for local communication or personal area network, I can go for Bluetooth. But if I want external communication, like a standalone, dog can run anywhere. Am I right or wrong? Do you think Bluetooth will help us? Bluetooth is low range. Na? I think within a room a dog is running, I'll be. But out of my house, the dog runs and goes away. That is why I'm developing this prototype. So Bluetooth will not help. If I want, I need to put an additional modem onto this space. Like a Wi-Fi modem or a GSM modem, I need to add on to this. That is what I need to look at. So Intel Genuino also, I'll just avoid at this point of time. So I'll be looking at other, like there is something called Intel Edison. So I'll not be getting into all this because I think you can have a look at all this. So different boards will be there, like Particle, Photon. Then finally, what I'll do is I'll come to this MediaTek Linkit one. See, that is why it is using MT2502 Aster SoC, as I clearly told you that. The advantage with this is I have Bluetooth, I have GSM, I have Wi-Fi, and GPS is also there inside. GPS is that for your location and all is there. So all the 3 communications are there inside this, luckily. So this board is a versatile board. If you want for a personal area network, you can use this board. If you want for a local area network, you can use this board. If you want for a wide area network also, you can use this board. For all those things, this board is there. So why can't I choose this? Only thing is a bit costly. I think currently it's 5,500 or 6,000 in the market. But this is a versatile board which I can use it for my development at this point of time. It eases my job. Or not, you need to add your additional thing like your Wi-Fi or Bluetooth or GSM and all. It will again create more add-ons basically, and you need to develop more things onto it. Because it's already there on the board, you can directly use them basically. So this makes a versatile thing. So what will I do is, now I need to select my development board for my application. So I'm going to freeze this board, which is called MediaTek Linkit 1 board. So now currently I have freezed this board. Now currently I freeze this board. I clearly told you that the advantage, the additional advantage I have, apart from being versatile, is it is based on Arduino. It's Arduino compatible. So you can use the same Arduino ID, just like for writing your sketches and all, you're using an Arduino ID. Same thing you can do for this. You have to just add this board into Arduino libraries basically. If you add this board into Arduino IDE, you can use this board with very ease. Same like Arduino, the same programming you are going to do on this. So that is the advantage we have in this board. Okay. So now it is very clear that we have frozen this board basically now. So we have freeze this board and we are going to use this board for our development today for demonstrating animal tracer. Okay, very clear. Okay, now that completes my step 1. So once that completes my step 1, now what I'll do, I have to go to step 2. Step 2 is the basic input I need. So what is your application? Animal tracer. So what are the features you are planning to give? So you look at, I want to give tracking, I want to give health, I want to give in contact. So I need to look at this step. What are the sensors required for that? Do I need an actuator for this application? And what is the communication you are going to give? Whether you are going to give Wi-Fi, you are going to give Bluetooth, or you are going to give something like GSM, or you are going to go with something new, as I clearly told you, something called as LP-WAN, that is low power wide area networks. Which one I'm going to use? So that is what I need to look at in step 2. So when I go to step 2, I'll be looking at the step 2. So the first is I need to identify the sensors and actuators if required, basically, and look at the various communication mechanisms. What is the best communication mechanism suited for my wearable, basically? So these are the two things I'll be looking at. So the thing is, first identifying the sensors and actuators for my application. So if I want to identify the sensors, so as I clearly told you that sensors are nothing but which give you information. Okay. So sensors are nothing but which give you information. So I need to look at what are the sensors required for my application, basically. So what I'll do is, so I'll put up some questions before jumping into which sensors I want to use. What do I want to measure? What are the parameters to be measured? What is the mechanism to be measured? Are the sensors available in the market? That is a very important question. Just don't think that that sensors will be available in the market. Okay, a lot of sensors we were using prior were all Chinese sensors, basically. Nowadays, I think you know that there is a ban on all these things. So we need to look at whether sensors are available in the market or not. All these things we need to have a clear picture. Just jumping into selecting all the things and sensors are not available, then you are in soup. Okay, so because your application is completely dependent on the input. So who is going to give you the input is a sensor. So based on the application, you have to select the particular sensor, basically. Okay, so for that, once I ponder these questions to me, and so I'll get into the functionality of the device. So what is that I'm going to do? I'm going to give tracking, I'm going to give in contact, I'm going to talk about health. So these are the three things I'm going to. Health is vast subject. So what are the parameters I'm going to give in health? I'm going to give temperature, pulse rate, and activity. So these are the three parameters, basically. Okay. So now I need to look at sensor for tracking. I need to look for sensor for in contact. I'm going to look at sensors for these three parameters under health, which is temperature, pulse rate, and activity. Okay, these are the things I need to look in my mind now. Okay, once it is done, what I'll do is I'll make a table like this. Before jumping to the sensor, I'll make a table like this. So what is the table I'll make is, so I'll put the functionality, I'll put up the parameter, I'll put up the what is the sensor required for the available sensor in the market. Okay, so the first thing, what is the functionality I'm going to give? I'm going to give tracking. So what are the parameters for tracking is location, that is nothing but latitude and longitude. And finally is what is the sensor I need to put? What is the sensor? So generally in our terms we call it as GPS sensor, but generally we need to call it as GNSS module, basically. See, today GPS means only American satellites. GNSS means it supports even what do you call that? European satellites, American satellites, Chinese satellites, and even Russian satellites, basically. So generally a lot of people have GNSS modules with them. Don't get confused with GPS and GNSS. GPS is only American satellites. GNSS is Global Navigation Satellite System. It supports these 4 countries, basically. So in future, even Indian thing is also coming up. It may support that also. Okay, keep that in mind always. In contact means what is the parameter? A touch. So what is the sensor required? That is a touch sensor. So then what we have is the health parameters. So for temperature sensor, pulse rate, heart rate sensor, activity, you know that activity is mainly based on orientations and all, it will be accelerometer sensor. So these are the sensors required for my prototype, which is animal tracer. But for demonstration to you, I don't have these 3 sensors, that is temperature, heart rate, and activity. I have location sensor and touch sensor. So I'll be demonstrating you with these 2 sensors. Okay, don't get confused. Okay, so in this version, what I'm going to demonstrate to you, I'll be showing you with 2 sensors, basically, that is the tracking and in contact, that is touch sensor. Okay, so let's get into these sensors now. So when I get into the sensors, the first sensor which I'm going to use is GNSS module. So what is GNSS? As I clearly told you that it's nothing but global navigation satellite system. Global navigation satellite system is generally what happens is on your development board, there will be a GNSS receiver basically. So it will receive the signals from the satellite. Once it receives the signals from the 4 satellites, it will fix it basically or lock it and give you the accurate location, that is latitude and longitude. Okay, always remember that if you look at this GNSS, generally what happens is in outdoor conditions you have better accuracy than indoor conditions. So generally previously in indoor conditions your GPS or whatever you call GNSS were not working, but later on there was support from assisted GPS and differential GPS. These are the new concepts which have come up. That is why today sitting in our room we are able to book Uber and all these cabs based on navigation and all we're able to do is because of all this. Prior to all this, only in outdoor conditions these things used to work. Indoor conditions they were never working. But now because of all this assisted GPS and differential GPS, you're able to sit indoor and also get navigation with accuracy basically. So always remember that you need to receive signals from at least 4 satellites so that you can accurately calculate the position and time. This is called lock or fix. Okay, lock or fix. So the thing is like this. This is about the GNSS module. But as I clearly told you that GNSS means it supports all these 4 countries, like GPS from America, GLONASS from Russia, Galileo from Europe, and BIDU from China basically. Okay, your module, if it writes GNSS, don't get confused. That means it's supporting with all these 4 countries basically. So that you get a more better position and time. So the thing is, if you look at this GNSS module, this is how. Then you may be questioning me, what about India, sir? Already India, a lot of things were happening like IRNSS and all those things. So what is that basically? So if you want to get into that, so that is why we need to look at Indian satellite system, which is called as NAVIC basically. NAVIC, navigation with Indian constellation it is called. So it's already coming up in the latest mobile phones. So I think in near future, GNSS may support this also. At this point of time, it is not supporting, but in near future, it is going to support basically. Okay. So this is what is called as IRNSS. It is, as you all know, that it is developed by ISRO, and we have already put up a lot of satellites into that. I think I think at least 11 satellites are put up till now, but in near future we may be getting more satellites so that we get a better picture basically. But one more advantage we have with this NAVIC is it covers both India, complete land and Indian Ocean also. And apart from that, they say that it's more accurate than GPS. So I think currently GPS and all they may be giving around a meter or 2 meters or 3 meters accuracy, but they say that this gives in better accuracy basically, very better accuracy, pinpoint accuracy and all they are saying. So let's hope for that coming up in near future basically. Okay, this is about the IRNSS. So as I clearly told you that current GNSS module which is there in our board is something called as MT322. It is supporting these 4 basically. Okay, GPS, GLONASS, Galileo, and BIDU. Not at NAVIC at this point of time. Okay, and the second thing is, as I clearly told you that we are going to use this touch sensor. This what I did is there is something called Brew starter kit basically. They generally have a set of 30 sensors inside their box. So I picked up that sensor. It's completely based on GPIO, that is general purpose input output. Okay, so GPIO we are going to use this. So the thing is the touch sensor works like this. Whenever whenever there is a change, that means whenever you put a finger onto that, there will be change in the capacitance, and based on that, it will change the value whether it's touching or not basically. Okay, so these are the 2 sensors what we are going to use for our demonstration today. As I clearly told you that this is the sensor. Okay, and this is completely based on the interface which we are going to use is GPIO. Okay. The next component is actuators. Do you guys think that we need an actuator? Frankly speaking, we don't need an actuator basically for this application. We don't need an actuator. But in near future, you think that a dog is outside your house, it should immediately close the gate or do something and all. You can still do, but at this point of time, we are not keeping an actuator for this application. We just wanted to give tracking, in contact, and the health basically. That's what. Okay. Okay. Now let's get into the next component, which is communication. How do we decide on communication now? What do we need? Communication. So what whether we need a personal area network like a Bluetooth or a Zigbee, whether we need a local area network like a Wi-Fi, or whether we need something called as a wide area network like GSM 3G, 4G, and so basically 3G, 4G, and apart from that, now currently people are talking about something called LP-WAN. I'll be talking about that also. So what do we need? So let's have a look at it basically. Let's have a look at it. So the thing is, whenever key requirements of communication in IoT, so these are the 5 requirements. Always keep in mind, whenever you are selecting any communication, it should match all these 5 parameters. One is long battery life, a communication which gives long battery life. Second component is low device cost. It can't be that my module, that means my IoT node is 2000 rupees, the communication module is 3000 rupees, adding to the cost, that is 5000 rupees. Who will buy your module? No one will buy it. So it should be very less, low device, low deployment cost. Deployment should be just like your mobile phone basically. Mobile phone today, are you struggling when you buy a new mobile phone? You just take a SIM card, go to a mobile vendor, sorry, mobile service provider, buy a SIM card and just put a SIM card. It's automatically working, am I right? Are you doing anything like setting up and all do things? Nothing we are doing today. Just put your SIM card, it starts working, it connects to the base station, nearby base station, and starts working basically. So that should be the thing. Okay, and extended coverage. Coverage should be extended. You can't say that you can't, my node will work only within this zone or within this area and all. No one will buy your thing. It should say extend coverage basically. And apart from that, it should support massive number of devices. You can't say that it will support only 100 devices or 200 devices or 300 devices. It should support, because IoT is talking about 50 billion devices. So your communication should support so many number of devices basically. So that is why, that is how you need to look at the key requirements communication. So once I'm done with that, once I'm look at it, then I'll get into the picture. So where do I need my communication? No. So the dog is going to stay only within the house, or it is going to run away anywhere. We know that the problem very clear is, if it is within the house, we don't need this system, this module, because it is running away. We need something like that, something like that. So for that, we need to look at what are the best things which are available in the thing basically. So the thing is, what I'll do is, let's think, why can't we use Wi-Fi? That is what we are talking about. Why can't we use Wi-Fi? Wi-Fi, the problem is, outside my house will Wi-Fi work? Because this module may be connected to my Wi-Fi. Outside the house, there will be multiple routers available. But will it be able to connect? Today only you tell me, your mobile phone within your house, it will be connected to your Wi-Fi. Once you are outside your house, it will ask for password for other routers, am I right? So Wi-Fi can be used. I don't think we can use Wi-Fi basically for this application, which is the dog tracer, that is animal tracer, whatever we call. Then what we can do is, we can go with the GSM. GSM, the best part is wide area networks. Anywhere, any place, anytime it works. So that is the advantage with GSM. But the biggest problem with GSM, what is foreseen is, just okay. The biggest problem with GSM, what we can say is, I don't want to get into the architecture of GSM, please. The biggest problem with GSM was not built for IoT. GSM, that is whatever you talk about, the 3G, 4G and all, they are built for what? They are built for audio, video and all. But in our application, we don't need all this. We need only data to be going. And the GSM consumes a lot of power basically. The wearable will drain off within days. As I clearly told you, the 4G, what we were using for the garbage bin, it was draining off in 3-4 days. But now we have changed the architecture so that it is happening up to 18 months basically. So these two problems are there with GSM. So how do we address it now? So for this, what people are doing is, they are coming out with something called as LP-WAN. That is low power wide area network, basically. Wide area networks. That means low power consumption, at the same point of time, longer range. So how do we give it? Low power at the same point of time, longer range. So that is why we need to look at this point of time something called LP-WAN. So this is what, that is what I was clearly telling you from starting of my session. Can the existing protocols work, or should we come out with something new protocols? That is what people are doing. They're coming out with something new which is addressing IoT problems. That is low power consumption, at the same point of time, longer range basically. So that is what we are looking at this point of time for LP-WAN. If you look at LP-WAN, this thing, so LP-WAN market which is there in the, there are two things. One is called as a proprietary market and one is called as the open source market basically. Open source market. In the proprietary market, that is we need to pay for the thing. So what happened is the 3GPP is there. As you all know that our standards like 2G, 3G, 4G and all, who is defining those standards for our mobile communication is 3GPP. So 3GPP is coming up with 5G now. But what they did is when 4G came, IoT market was full. People started using 4G, but the problem is their battery was dying. Then 4G that concerned body, they felt that why can't we come up with some new protocol which is called NB-IoT, that is called narrow band IoT basically. So that is which is promising 10 years of battery life and 20 to 30 kilometers of range basically. So they felt that NB-IoT is very good for that. So at the same point of time, if you look at a low battery, that means 10 years of battery life it is promising and range also it is promising basically. So people are looking at this something called as NB-IoT now at this point of time. Always keep that in mind. Okay, keep that in mind. So that is what which has come up. But only thing is near future also. At this point of time, what is happening is you may be asking, sir, whether NB-IoT is there in India or not for usage. So in Bombay, Samsung and Jio are testing it in Bombay at this point of time. So once that is done, near future you can directly use it. So NB-IoT is also just like 4G only. You have to just buy a SIM card and put it in your IoT node. It will start working. But advantage what we are getting is 10 years of battery life. That is what we are getting this. Okay, and there are a lot other protocols like Sigfox, RPMA, and all those things. There is one thing called LoRa, which is very famous, which is generally considered to be open because we need to only pay for the modem. We can directly create our own network with LoRa basically. That is why it is called as long range basically. So a lot of people are talking about it, and we are also using it for our developments now. So like garbage bin and all, we are using LoRa at this point of time. This also is promising around 10 kilometers because we have tested practically also we got around 9 kilometers to 10 kilometers basically. And the battery life also it's giving the promising 5 years to 6 years of battery life. So that is what we are looking at this point of time. So the thing is LP1 market, if we look at, so just give an example of what this LoRa is and all those things. Just advantage with LoRa is it's working on ISM band. So we need not, just like your Wi-Fi and Bluetooth, are you paying for using Bluetooth? Are you paying for using Wi-Fi? You're not paying anyone. You may be asking that for but WLAN routers I'm paying. You're paying only for internet boss. You're not paying for Wi-Fi. Wi-Fi and Bluetooth are working at 2.4 gigahertz, that is ISM band, which we call it as industrial, scientific, and medical band, which is unlicensed. But for using your mobile phone and all, you're paying a service provider because service provider is going to pay for the spectrum. I mean, that is proprietary. But your Wi-Fi, Bluetooth are not proprietary basically, they are ISM bands. The same way LoRaWAN also works at ISM band only. But in India, it is working at 868 megahertz, which is ISM band for India. Okay, always remember that. In India, it is working at 868 megahertz, which is ISM band for India basically. Okay, so the thing is, if you look at LoRa architecture as a whole, I'll just get into. So the LoRa architecture looks something like this. These are the LoRa nodes, which means the sensor nodes, which is having LoRa. Always remember that LoRa will have a gateway in the middle. Its architecture defines that you need to put up a gateway in the middle. And finally, the data will come to the network server. On the network server, it will be processed and given to various applications basically. So always keep in that mind that LoRa always has a gateway. So tomorrow you want to set up your own network, you need to put a gateway. Either you can develop your own gateway or you need to buy some gateways basically. Always remember that. But it is open, you can set up your own networks. You are not dependent on anyone. But in case of NB-IoT, the problem what we have is we are dependent on either Airtel or Idea or Jio to come up with their own base stations basically. Okay, here you should be worried about LoRa, you should be worried about the infrastructure. But in NB-IoT, you are not worried about the infrastructure because that is already put up by your MSPs, mobile service providers. Always remember that. Okay, so LoRa is that. I clearly told you that it is working on the ISM band basically. Okay, ISM band. Next, come to NB-IoT. As I clearly told you that NB-IoT is the one which is developed by 3GPP. The advantage with it is, see, if you look at it, is having 10 years of battery life, easily deployable because already we have base stations where you can deploy it. And one more thing is the advantage what we are having is Jio with Samsung is planning to deploy NB-IoT in India. It's already set up. Their is testing it. Once this is done, it may come up in India completely. But the advantage with LoRa, what we have is currently Tata has put up gateways, so where we can use their services basically. So LoRa has a much proliferation in India than NB-IoT. NB-IoT is not yet proliferated in India. So today, if you want to use, you can use LoRa, not NB-IoT at this point of time. Okay. So to give you a clear picture that I'll jump into NB-IoT, I'll use NB-IoT, but you need to check whether NB-IoT is there in India or not. Not yet. It's going to come up then. So at this point of time, if you want to use any LPWAN protocol, you can use LoRa. Okay. So which one is the best? As I clearly told you that LPWANs and all, you need to make a study of all these LPWANs. So the thing is, this is unlicensed, this is licensed. So data rate is generally never looked at in IoT because only in bits and bytes we are going to do. So only thing is which is the most important is battery life. Battery life, LoRaWAN is also good, NB-IoT is also good. Okay, all those things we need to look at basically. And the biggest component which we need to look at is easy ready in India. As I clearly told you that Tata Communication has already started put up in gateways, you can use their services. But in NB-IoT, we are not at, they started testing Jio and Samsung are testing. So it may take some time. So we need to look at these two things. So the thing is, now, as I clearly told you that every communication, every protocol will have its own pros and cons. We have to choose the best and go ahead with them. Okay. So now, what do you think we should choose for our communication? So everyone will be telling, surely go for LoRa because LoRa is having good range and all those things. But the problem is because at this point of time, I'm going to do something called rapid prototyping. I'm not developing a product. If I'm developing a product, I would have gone for LoRa. But because prototyping, I want to just demonstrate it to you. I'll use whatever is there on the board instead of adding an additional board to my development board. So currently, I'll use GSM for my demonstration so that I can complete off my prototyping. I'll test it. Once it is done, then when I'm moving to the product, I'll go for LoRa basically. Okay, so don't get disappointed that I spoke about LoRa so much and using GSM, but because I'm doing rapid prototyping at this point of time, so I have to go with which is available on the board. So I'll go with GSM only. Okay. As I clearly told you that GSM, there is a GSM controller on the board. So that supports us to use GSM and all. So there is a SIM slot with the board where you put up the SIM, it starts working. Okay. You have to just use the APIs of Linkit1. That is the GPRS APIs of Linkit1 basically. Okay. The thing is that completes my step two, and now I go to step three. Step three, so step three is nothing but a dashboard, cloud dashboard basically. Cloud, how do we select and what is the development cycle for that? So the thing is, if you look at the complete, because there are various platforms available in the market, we need to select which platform we want and all those things. Because don't get biased with whatever I say. You also look at which, because a lot of people have already started working on ThinkSpeak, UV dots and all. But what did I choose is, the thing is, generally what happens is we need to have a platform where our data comes onto the server, gets stored, and that means we need to have a database so that we can retrieve that data basically. So for that, there are so many platforms available in the market, but some platforms which are available are PubNub, UV dots, ThinkSpeak, MediaTek Cloud Sandbox, and so. No, I'm talking about only free clouds. Don't think that why he's talking about only this when Azure is there, AWS is there, all these things are there. I'm right. Watson is there. But these are free platforms where you can do your prototyping basically. When you're going for a product, you can choose Azure or AWS and so. But for your prototyping and so, I would prefer that you go with these things. Okay. But currently for showing you guys, I've chosen this MCS, which is nothing but MediaTek Cloud Sandbox. Because the one advantage I have is it's completely developer friendly and user friendly basically. And features are also very good. Okay. If you look at what are the features available there, the features available, I would say that is a lot of things are there, and it uses something called as RESTful APIs, which are lightweight APIs, so that you can do, and it gives a very good dashboard also. It gives a very good dashboard also, and one more thing is the number of devices it's supporting is around 10. The number of devices it's supporting is around 10. So supporting is 10 means for prototyping you can use 10. If you want more, you have to pay them. That is what. So currently I'm using MCS for this. So the advantage is what I'm getting is a lot of things are there. You can define push pull data, remotely control, manage, create reports, firmware over there. That is what today people are talking about, something called as the FOTA basically. That is the firmware over there. See today, can you one thing you tell me? For example, today I'm putting an IoT node into the field. I want to make some changes. I want to make some configuration changes. Okay, for one device you can manually go and do. Two devices you can do. 100 devices you can do. 1,000 also I can think you can do. But if it's billions of devices, you'll be able to manually do it. You can't be able to do it. Today for your mobile phone, any update come, what is happening? It's picking up from the server. The same way your IoT nodes tomorrow should be able to pick it up from the cloud. That is why that is what is called as firmware over here basically. So whatever configuration changes, you'll put it on the cloud. That will get updated onto your IoT nodes basically. All that features are given by this cloud. So what more you want? What more you want? So this is what is the MediaTek Cloud Sandbox, which we are going to use. So now we'll get into how to development cycle of MCS. See, as I clearly told you that I'll not completely get into this. I'll just directly show you the cloud so that you'll get a clear picture of what is happening. So this is how the cloud looks like basically. The cloud completely looks like. For example, so anything you want to develop, you have to put it up as a prototype basically. Okay, you have to select the prototype, and in that, because on this dashboard you should say what are the parameters which you need to come. See, for example, what happens is I need to create see what all parameters I need. As I clearly told you that I need location, so I'll put a location. I need in contact, I'll put in contact. I need temperature, I'll put up temperature. I'll pulse rate, activity, battery level, configurations, counters, all these things I'll be putting up basically. Why I'll put up all these things is, as I clearly told you that based on these parameters only, the data will come exactly onto this basically. Okay, so this is how you need to set up the dashboard. Dashboard setting up is very easy. I'll just, you need to just log in into that. Once you log in, as I clearly told you that there is something called prototype and test devices. Prototype and test devices. So I need to click because I'm going to develop a prototype today. So I'll click the prototype. Once I click the prototype, it will ask the information, what do you want it, which board you are using and all this. Upload some image for that and all those things. So once you fill up this data, once you fill up this information, it will ask add data channel. So these are the data channels where your parameters will come. Your sensor data will come here. Always remember that. You should be very clear. So when you are developing, when you are setting up this, you should be very clear that two things are there. Always remember that. Every device will have its own ID. So that is given by the cloud. Don't worry about it. The device ID is given by that. And every data will have a channel ID, because the temperature will have a different channel ID, humidity will have a different channel ID, battery will have a different channel ID. All these things will have a different channel ID. Because based on those channel IDs, you put it in your code, the data will come onto the dashboard exactly. Always remember that. So now the thing is how the data will come. If the data will come from the sensor to the cloud, or the data will go from the cloud to the sensor, because both are possible. Am I right? See, tomorrow you want something from the sensor to the cloud, sensor data will go to the cloud, and even from the cloud you can process and the data can go to the sensor for doing some action. Am I right or wrong? So both the ways are possible. So that is why what these cloud guys have done is they have named them as display and controller basically. Display means the data which is going from the sensor to the cloud. For example, temperature, counter, information and all. Controller is nothing but the data which is going from the cloud to the sensor node basically. Always remember that. There is a hybrid mode which we generally don't use, which is both. It can act both as a display and a controller basically. Just keep that in mind. Display means just the data from the sensor has to go to the cloud. Controller means the data has to come from the cloud, from the server to the sensor node basically. Okay. So now what are the variables which are required for our project? The variables which are required for our project is, that is the reason we put up like location. Yes, I need location, in contact, temperature, pulse rate, activity, battery level also I'll put up, because I need to know which battery, and set configuration. There is a one option in this cloud also. The advantage what is you can set the configuration telling that based on the battery level, what we can do. My sensor based on the battery level. For example, today you take up your mobile phone. What is happening? 100% means all your features will work. When it is in 20%, what will happen? When it will ask low power mode, when you click that low power mode, now what happens is some features may get reduced, like brightness may get reduced and all this. Why? Because it want to give more life to your mobile phone. Because your mobile phone main purpose is incoming and outgoing calls. All other features which are there additionally are generally switched off, so that your incoming and outgoing is time is increased basically on your mobile phone. The life of your mobile phone is increased. The same way you can also set up the configuration, telling that when the battery is 100%, send all the sensor data. When the battery is only 50%, which is more important for me, tracking, only send location data. If the battery is 10%, if the battery is 50%, you can say location and in contact. If the battery is only 10%, send only location. Like that, you can set configurations. So that is what we need to keep that. So these are the parameters which that is the reason if you look at, in the thing, these are the parameters we have put up basically. See, location, in contact, temperature, pulse rate, activity, battery level, set configuration, present configuration, counter basically. Counter is nothing but which tells me this is the current packet. See, when did the last packet come? 1346. That means just 1 minute back the packet has come basically, because I've switched on my board and switched on the dashboard basically for you guys to demonstrate. Okay, so this, see, now the new packet has come, 82nd packet, just 147 at this point of time. Okay, so the thing is like that we need to configure this. I think I'll not get into much detail of all this. Just I'll share my slides so that you can look and do it basically. So this is how it gets added basically. When you add a dash, so everything you need to add. So this is how you can set your configurations also, so that okay. So the thing is like this. So our dashboard will come up once that is done. So if you want any action, see, as I clearly told you that device ID and device key is given by the, is going to give, your cloud is going to give you that. Okay, cloud is going to give, and like that will be getting different applications. Okay, so this is how your board will look like basically, the Linkit One board with all the sensors integrated onto it basically. So currently only the touch sensor and what is that, temperature sensor are interfaced. So these are the antennas basically. This is the GPS antenna, this is the GSM antenna, this is the battery basically. Okay, very small board with all these features basically. So you can connect your device onto it and you will be able to see. Okay, the thing is that completes the step 3. Then we'll go to step 4. So what is step 4? Step 4, as I clearly told you, that you need to set up the development environment. Setting up the development environment is very simple. The thing is it's pretty clear. Like Arduino ID, I think you all might be having Arduino ID. You need to just add a plugin to Arduino ID. That is, I think literature is already there in the internet. Just type Linkit One for Arduino ID. It will give you a patch. You have to just integrate. So once you integrate, it will just be like this Arduino. It will be working basically. You can write your own programs onto it. So one thing you do is, whenever you add this board, in the board configuration, it has to show this board like Linkit One. If Linkit One is there, that means you have added your board. If Linkit One is not coming, that means there is some problem. You have to again do it basically. Always be very clear. So this is how you do it. And finally, you have to run your programs just like Linkit One only. Okay. So once that is done, I think not get into all this because I think writing a program and all these things is very clear. I think you can write your own applications. Just look at all this. See, one thing is, always any doubt you have, which API to use, which class to use and all, you have to go to their interface documents, reference documents, where you can go and write, see their classes, what they have done, and use those classes basically. And before that, I would suggest that don't just jump into that. Before that, just to go to file, and examples are there. In this, lot of examples are there where you can check what are the programs, how to write, and for GPRS what is the thing, for GPS what is the thing, and all those things. You just look at them and execute those programs. That will give you a clear picture of writing the bigger programs basically. Okay, always remember that. See, these are the examples where you can go and check these things so that you get a clear picture of how to use this. So in the same way, touch sensor, then programming interface also, we have used GSM. So I'll go to GSM GPRS classes basically. So don't directly jump into that. You have to just one thing you always remember that whenever I'm pushing the data to the cloud, whenever I'm pushing the data till now, it is MediaTek Linkit One board. Whenever I'm pushing the data to the cloud, you need to use cloud APIs. Okay, you need to use cloud APIs. Cloud APIs, you need to use two APIs. One to push the data onto the cloud, one to retrieve the data from the cloud. So for pushing the data, you say post. For pulling the data, you say get basically, get. So there will be one thing, always remember that. I'll just show you that. Under the resources, there is something called API references. So under these API references, he has given the complete how to push the data and all those things basically. You can look here and do this, like upload data points. So what is the format? For retrieving data points, what is the format basically? So like that. Okay, so that is how I need to look at the various things and do it. Okay, so like this. That is what I'm just showing you guys. So the thing is, this supports different formats like the CSV format, what is other format, the JSON format, and all those things basically. So finally, the data will come to the cloud like this. Okay. So one thing I'll just show you. I'll just 1 minute. Yeah. See, the thing is, I am executing a program now onto the cloud. The data is coming directly live onto the cloud basically. If you want to look at, you want to verify that the data is coming directly to the cloud. See, you can just check. So I'm sitting, my office is very near to the airport. So it is showing the live location at this point of time because my sensor board is in my office. So it is coming. So the thing is, as I clearly told you that I have only GPS sensor and in contact sensor. If you want to see the in contact, see currently no one is touching it. Okay, the sensor. But now I'll touch in my next packet. You can see that in contact has become S. Why it has become S? Because I'm in touch with the sensor basically at this point of time. Okay, this is the latest packet which has come, that is at 153 basically. So now I release it so that so this is how your data will come onto the dashboard. And one more, so you can set up basically whether you want idle part or full or whatever you want, you can set it up basically accordingly. Okay, this is the complete dashboard what we have. So this is the live data which is coming for you guys, which I was showing you. So you can set up various applications like as I clearly told you that you can write your own algorithm and push it up. So currently I'm pushing up this algorithm where I'm sending it different data basically, okay, based on the thing. So like that, finally the data comes onto the cloud. Okay, so that finishes my step 4. And as I clearly told you in step 5, we need to look at the challenges. So what are the challenges available? As I clearly told you that don't think that whatever we have promised we can give. Always remember that some features we need to look at where we can deliver or not. We need to see what is the value for the product. What are the practical issues like the IP resistance? What is the power, scalability, cost? And as I'm telling you, in the prototype, you learn a lot of challenges. Basically, you will get a lot of challenges, face it, and then go ahead for the product. Okay, that is what I want to say. So these completes my step 5 also. So I complete all the steps and your prototype is ready at this point of time, which is the dashboard is coming onto the dashboard now. The live data is coming onto the dashboard now. You see, because now I'm not touching it, again it has become no. So this, and I clearly told you that temperature, pulse rate, activity, we don't have these 3 sensors at this point of time. That is why it is showing only 0. Okay. So now currently the battery is 100%, so it is showing 100%. Okay. And this is the counter. See, every time it's increasing whenever the packet is coming to the cloud. This is the live data which is coming. Okay, this point of time. So this is how I complete my session today. That is idea to prototype to product basically. Okay. Any queries or anything you can ask me. I think I'm done.
Yes, dear participants, sir is open for any queries, any questions.
What are the security concerns related to IoT? Yes, security concerns are always there, as I clearly told you yesterday also, I think day before, because the IoT is looking at constrained devices, which is low power, low memory and all. So security, adding the security is a big challenge because we need to have something called a lightweight protocol, lightweight security. Now we are working on IoT security. We have just started working on that. So in my near future sessions, I'll be talking more on IoT security also. Okay, so that after gearing up some expertise onto that, I'll be sharing you what exactly we can do for IoT security. Okay. 3GPP, yeah. The thing is, as I clearly told you that now because 3G, 4G and all, as you all know, they're basically designed for audio, video and so. But IoT doesn't need audio, video and so because they're constrained devices. Constrained device. 3G, 3G, 4G and all are made for especially resource-rich devices like your mobile phones, laptops and all. So now for IoT, they are converting that into something called NB-IoT basically, narrowband IoT. So that is what they are looking at even in 5G. 5G, they are looking at NB-IoT that will be looking at IoT concepts basically. Okay. In prototype, do you create architecture diagram? Yes, I think you need to create an architecture diagram so that you will get a clear picture of what is needed and all, what are the components needed and all. Because I didn't put up an architecture diagram, but you guys have to put. Because always remember that even I tell my youngsters who are working with me that never don't directly jump to write code. You have to first design and then jump to write code. Okay, always remember that. First to put it on paper and then get into the code. Okay. Yeah. Sir, any other things?
Sir, the same thing. I think in the next session you may be covering it. When billions of connected devices are available, how
Yes.
I can store my device? Because say for authors there is a IPR, copyrights. For
Correct,
goods is a patent, and for these applications, how can get my right registered so that no one else can copy it?
Yeah, sir. That is why I think now IoT with blockchain is coming up into the market because any sort of a tampering, any sort of a hacking is there. Blockchain will create a ledger for that. So that is what people are working at, sir. But the problem is at this point of time, still it is at a very, I would say, nascent stage. It's not yet matured. But I think in near future, I think within the span of an year or so, the technology will get matured. Then I think I'll be presenting on that. Then it will be having more pictures, sir. I think
Yes.
at this point of time, I'm
Yes,
not able
yes,
to
yes.
claim at this point of time, but surely that will come up into the market. Okay.
So that means a lot of theft can take place in the meantime.
Yeah, sir. I think already a lot of things are happening also. If you look at a lot is Alexa device and all, people are able to get inside their house and change the music itself, change the lights and all. A lot of things are happening. But I think that
Yes,
will get
yes.
reduced once these technologies come into picture, sir. I think it will take some time, but it's a challenge. But I think a lot of work is happening. I think within the span of 6 months to 1 year, we'll see a lot of changes. Yeah.
Yes. So, sir, nicely you have listed out various steps
Yeah, sir.
to that idea can be matured and you can turn it in IoT applications.
Yeah.
Now over to our chairman. He wants to convey his vote of thanks to you.
Yeah, sir.
Just wait a minute, sir. Yes, over to you, sir. Over to you, sir. Yes.
Thank you very much, Professor Rathiji. Really, I'm very, very grateful to Dr. S.B. Srikantji. Sir, I don't have any word how to express it. The way you have presented and the way you have conveyed your vast experience to participate, it's memorable. Our Honorable Vice Chancellor of Rajasthan Technical University, Professor R.A. Gupta, just he called up and he was praising like anything. He said to convey his best regard to you and
Sure,
on
sir.
behalf of RTU, on behalf of Shankar Group of Institution, now we both have become more greedy towards you. So time to time we will be requesting you and once again, I'm requesting you if there is any possibility a word of confirmation will be great honor for us. Tomorrow we are having valedictory session at 2 p.m. So if few minutes you are sparing, So if you are sharing few words, so our dignitaries like few from Government of India, from Rajasthan Technical University, we all will be there together. So is there any possibility to be there at 2 p.m. tomorrow for
Sir,
few minutes?
yeah, I can't confirm at this point of time, sir, but I'll try, sir. I'll try my level best to join. Okay, sir.
So
Please don't mind.
kind
Yeah, sure. Right.
what I can request that with your kind permission, just I'm putting your name and validation and between 2 to 2:30 or 2:40 anytime. Suppose if there is any possibility in between, you can join.
Sure, sir. Sure. I'll look at it.
And
Thank you, sir.
so we are very, very grateful. I hope that you will not mind for any inconvenience. We have disturbed you again and again, but for the benefit of the society, for the benefit of the future of the nation, future of the world, students and faculties are the key person who will help our society. That's why we have troubled you, and in future also, I pray you kindly spare few minutes, few this moment to deliver your vast experience. Once again, thank you very much, and
Thank you, sir.
this is a token of love and affection from our Shankara group of institution and RTU, a memento that will remember you. Kindly accept a token of love.
Thank you, sir. Sure, sir. Thank you, sir. Thank you very much for that.
Welcome, sir.
Thank you, sir.
Thank you,
sir.
And
Thank you, sir.
all participants also.
Yeah.
Welcome.
Thank you. Thank you all.
Okay.
Yeah. Bye.
So, to all the participants, thank you very much for raising in between a lot of queries. And tomorrow we'll be here at the same time, at 10 o'clock. First session will be at 10 o'clock. And sessions will continue. And after the second sessions, there will be valedictory address. So thank you all, and goodbye for today's sessions.
Excuse me, Professor Adiji, just to announce in valedictory session, our Honorable Vice Chancellor, Professor R. Gupta ji will be there. Dr. P. Chandrasekhara, he is the Director General of Manage Hyderabad, he will be there. Few other dignitaries. So valedictory session will be also very, very useful to all participants. So we are requesting all participants, kindly spare your valuable time during valedictory session also. Thank you very much.
Thanks, sir. Thank